Hi everyone, welcome to Vedantu NEET English. I'm Diksha, your chemistry master teacher. How are you all? Very good evening to everybody here. Very good evening everyone. So join in fast for alcohol, phenols and ether. As you said ma'am, we want to complete our biology class. So I even gave you 10 minutes break. So now it's the time for chemistry session. Okay, so we are going to complete this whole chapter in detail along with the mechanisms and PYQs and the tricks and the conversions, important conversions. So everybody join the session fast. Everybody in the chat box, join the session fast. Okay, so that we can start this session. Okay, yes, perfect everybody in the chat box. Yes, hello Farhan, Keith, Noora, Kavya, Pavish. Very good evening everybody, very good evening. So how's the Josh? How's the Josh everybody? How's the Josh? Have you taken the rest? Are you relaxed now? Should we start the chapter? Everybody in the chat box, should we start the chapter? Alcohol, phenols and ether, a very important chapter of organic chemistry. So many questions are asked from this chapter itself. So many questions, like most important chapter of NEET. Okay, hello bacha, hello. So let us start this session, alcohol, phenols and ether, where we are going to cover flow charts like this. Okay, so we are going to cover these kind of flow charts also, right? These kind of flow charts where you have to fill the blanks here. We are going to cover all these flow charts here. Okay, these flow chart, this flow chart we are going to complete, and I will give you one flow chart for your homework. So everybody, please listen to this session very clearly, and even if you stuck somewhere, just let me know. Wait a minute. If you stuck somewhere, just let me know that ma'am, we are not able to understand. I'm here to answer all your queries. Just be 100% focused while we are doing this session. And you know, that will be great if you have pen and notebook along with the session, so that you are able to draw the structures also, so that you are able to understand it more clearly. Okay everybody? Yes, sure, class 11 should see this, because 1 year you are just 1 year after this to 12th. If you want that, this basically, if you know GOC and you are learning all these chapters in 11th class, that is going to help you in 12th class, and in NEET preparation, the load for 12th class will be so low for you. Right? So yes, 11th class students, 12th class students, CBSE board students, NEET students, all of you can see this session. So let us start this session everybody. Let us start this aldehyde ketones tomorrow or after tomorrow. I am going to teach you aldehyde ketones and carboxylic acid on Thursday, okay? Day after tomorrow. Don't worry about it. Okay, and amine I will teach you amine on this Sunday. We are going to cover amines this Sunday and biomolecules after your English session. Okay, so don't worry about it. We are going to complete everything, right? Okay, so let us start with a very basic statement. I am going to go from basic level to advanced level. Okay, just be very focused here. So let us start, everybody in the chat box. Let us start, everybody. Put fire in the emojis. Put fire emojis in the chat box so that I can know that you are ready for this session. Everybody. Yes, Sarth. Hi, bacha. Hi, everybody. So put fire emoji in the chat box so that I can know that all of you are ready for this session. Okay. Yes, I am waiting for your reply, everyone. I am waiting for your reply. Yes. 1, 2, 3, 4, 5. Yes, very good, awesome. So let us start this session. Classification of alcohols. So how alcohols are classified? They are classified as monohydric, dihydric, trihydric, polyhydric. Mono means having one OH group, di means having two OH group, tri means having 3 OH group, and poly means having so many OH groups. Okay, having more than 4 OH group is called polyhydric alcohol. Right? OH is the main functional group here of alcohol. So for monohydric, you have 2-3 things. Okay, like we did in haloalkenes. Same way, in monohydric, if you have one OH group, if that is attached to sp3 directly, like you have For example, you have this double bond, okay, and you have this carbon, and here OH is attached here. So as you know, in this case, this OH is attached to this sp3 hybridized carbon. Okay, this is called allylic alcohol. Okay, this is called allylic alcohol. For example, you have this double bond, and this OH is directly attached to this double bond. Now this OH is attached to one sp2 hybridized carbon atom, right? So this is vinylic, okay, this is vinylic, and this is allylic, and what is benzylic? For example, you have this benzene, right, and this OH is directly attached here. Okay, this is aryl. Okay, this is aryl when OH is directly attached to a benzene, right? That is aryl. This is also called phenol, right? If you have this benzene and there is one carbon atom attached to it, this OH is attached to a carbon that is directly attached to a benzene. That is called, now this is sp3 hybridized, okay? This is called benzylic. Okay? This is called benzylic. So monohydric is also divided in this way, right? Okay, everybody? Clear to everyone? Simple terms, yes. Perfect. Now, let us understand this chart. So, this is alkyl alcohol, very simple alkyl alcohol. This is a normal chain that is attached to OH. Allylic we have discussed, benzylic we have discussed. These both, allylic and benzylic, are attached. The OH group is attached to sp3 hybridized carbon atom. And here in case of vinylic or arylic, you have OH group that is attached to sp2 hybridized carbon atom, right? Okay, so next we have alkyl alcohols are further divided into 1 degree, 2 degree and 3 degree. 1 degree is that when the OH group is directly attached to a carbon that is further attached to just one carbon atom. 2 degrees when the OH group is directly attached to a carbon that is further attached to 2 carbon atoms. Okay, this is CH and this is OH, this is R and this is R. So this carbon atom is attached to further 2 carbon, that is secondary. Tertiary is that when the OH group is directly attached to that carbon that is further attached to 3 carbon atoms, that is tertiary alcohol. Okay, and 1 degree, 2 degree, 3 degree, they have same functional groups. Okay, now coming to this is 1 degree. Now this is allylic. In case of allylic, we have 1 degree, 2 degree, 3 degree. Now, if you have OH that is directly attached to that carbon atom that is further attached to just one carbon atom, but also it is allylic in nature, that is 1 degree primary allylic alcohol. Here in this case, this OH is attached to one carbon atom that is further attached to 2 carbon atoms, that means it is secondary. But also this sp3 hybridized carbon atom is attached to double bond, that means it is also allylic. In this case, this OH is attached to a carbon atom that is further attached to 3 carbon atoms, that means it is tertiary. But this carbon atom is also double bondedly attached. This is also attached to a double bond, carbon-carbon bond, that means this is allylic in nature. Okay, yes bacha, I am going to start. Okay, don't worry, I am going to start. Okay, so then there comes benzylic. For benzylic we have 1 degree, 2 degree, 3 degree. Same case, this OH is directly attached to carbon, benzylic. This OH is directly attached to a carbon that is further attached to benzenic, that means it is benzylic. Also this carbon is further attached to 2 carbon. This is first carbon, this is the second carbon. This means this is 2 degree carbon atom, 2 degree alcohol. This is 3 degree as this carbon atom is further attached to 3 carbons and this is also attached to 1 benzene. That means it is benzylic 3 degree carbon atom, benzylic 3 degree alcohols. Right everybody? Now we have classification of alcohols. How alcohols are classified, right? These names are very important. Then what is catechol, what is resacinol, what is quinol? They can directly ask you what is the structure of these 3, right? They have mentioned in your NCERT. After my session, you don't need to read NCERT because I have covered everything that is mentioned in your NCERT, right? So this is phenol. For phenol, we have monohydric, like phenol monohydric, that means just one OH is attached here. If two OH is attached here, from the ortho that are ortho to each other, that is catechol, that are meta to each other, that is diazonol, that are para to each other, that is quinol. Okay, if you have three OH attached to this, like you have, these names are not so important for you, these names are important for you, these are not so important for you, these three are important for you. Okay. Now let us start the preparation of alcohols. Okay, preparation of alcohol. You will see that so many questions are repeated from hydrocarbons, and also when you will read aldehyde ketones and carboxylic acid, that would be very easy for you. Why? Because we have already done in detail all the chapters, so many reactions will be repeated here. Okay, so let us start from alkenes. We have studied alkenes in hydrocarbons, right? So from alkenes, first is by acid catalyzed hydration. Always remember, in this case, always rearrangement, always I am giving you the hints here, okay? Always the rearrangement of carbocation happens here. Always in case of when you have to make the product by acid catalyzed hydrolysis, in that case you have to firstly make the carbocation and then rearrange it, and then you will form the product in that case. Understood? Okay, so why, what is the mechanism? The mechanism is that you have this H positive. Even if you don't know the mechanism, you should know the important part of that mechanism, how this proceeds, what is the process, what is the rate determining step of this mechanism. So the rate determining step is the formation of carbocation. Okay, so in this case you have this H2O, which is in the acidic condition, it will form hydronium ion, right? This hydronium ion is going to attack on the double bond, and it will form a carbocation here. It will form a carbocation here. Okay, it will form the carbocation here, and after that rearrangement of that carbocation will occur. You will have this carbocation, rearrangement of carbocation will occur, and after that you will have the formation of that alcohol. Okay, after that you will have the formation of that alcohol when you are choosing the product. So how this mechanisms proceed? You have this carbocation. Now this H2O, it has lone pairs, and this is electron deficient. So these lone pair are going to attack on the electron deficient carbon atom, and hence it is going to form this. Now this oxygen is electron deficient because it has shared the electrons. Now what it will do? It will take away the electrons and will lose water from here, and you will have the it will actually lose H positive here. Yeah, it will lose actually H positive here and will take away the H positive. Yes. Okay, so what will happen here? You will have this. Okay, so it will take away the electrons from this bond, and it will take away the electrons, and this lone pair will attack here. Okay, so and that is how you will have the formation of alcohol. So now let us see what is the important part here. What is the important part here? So I am going to draw a reaction for you, that is C double bond C. You have this CH3, and then you have this one. So now tell me, what is going to be the product for, acid catalyzed hydrolysis? What is going to be the product? These questions are asked, okay? These type of questions are asked in NEET examination. Because you have three kind of hydrolysis. One is acid catalyzed, next is diborane, and third is demercuration, mercuration. Every single, these three are totally different. They will have different products. Everywhere you will form alcohol, but the products will be different. Okay, so how you are going to form the product here? First you will form the carbocation here. Okay, so first you will form the carbocation here. How you are going to form the carbocation? This pi bond will break here. Either here should be positive, either here should be positive. Tell me, either which positive you are going to select, on the first or on the second. Which positive do you think is more stable? Which carbocation is going to be more stable? This one or this one? Which carbocation is going to be more stable? This carbocation is going to be more stable because of resonance effect here. This carbocation is going to have just inductive effect. So in this case, we are going to select this carbocation, the formation of this carbocation, and hence we are going to have, the product as, this is your benzene, this is CH, this is CH, this is CH3, this is CH already, this should be CH, right? Okay, So here should be CH2 and here should be OH. This is going to be your product, okay? This is going to be your final product in this case. One more example here. One more example here. For example, you have a product that is, you have a reactant. Okay. So yeah, tell me what is going to be the answer to this. By acid chloride, by acid catalyzed hydrolysis, what is going to be the product here? Firstly, what you need to do, you need to select the breakage of pi bond and where it is going to be positive, where it is going to be negative. The positive here will be selected. The positive on this case will be selected and here should be negative, right? Because in this case, carbocation will be more stable as comparison to this one. So it will firstly form a carbocation that will have this positive and one hydrogen here, okay? This will be the formation of carbocation in this case. First we break the pi bond and just form the more stable carbocation. Here this positive is more stable as compared to positive here and negative here, okay? As compared to this condition is more stable here. So I have made this carbocation. Now as you can clearly see, this is 2-degree carbocation, okay? This is 2-degree carbocation. When I am going to rearrange this, carbocation, this will be more stable by 3-degree carbocation, right? And now the final product, but the final alcoholic product will be this. The final alcoholic product will be this one. Okay, everybody, that is how you are going to solve these kind of questions, right? Okay, everybody, yes. Now let us do the second case, that is hydroboration oxidation. In this case, no rearrangement. In this case, no carbocation, no rearrangement. Okay. In this case, no carbocation, no rearrangement. Firstly, just take that. Just consider that thing. Okay. So now let us see what is that reaction. Here also you form alkene. You form alcohol from alkenes, right? And the reagents are diborane, THF, H2O2, OH, negative. Right? Okay. This is peroxide. By peroxide, you can get an idea. By peroxide, you can get an idea that here we will follow anti-Markovnikov addition. Okay, here we are going to follow anti-Markovnikov addition. That is the main key point here. That is the main key point here. The anti-Markovnikov addition we are going to follow here. So for example, taking the same example here, firstly let us see the mechanism. Okay, this is diborane. It is going to attack on this double bond. One H will be here, one BH2 will be here. Okay. Then diborane will attack on the second alkene. This second alkene is going to attack here, and then third alkene is going to attack here, and you will have the formation of this one. Okay, like in case of BH3, you have BH3. Just replace this H by CH3, CH, this CH2, this is H, and this. Okay, just replace this according to this. Just replace BH3 by this compound. Okay, so you have this compound now, right? After hydrolysis, you will have the formation of alcohol here. After hydrolysis, you will have the formation of alcohol here, and that to anti-Markovnikov alcohol. Now let us see the questions here that are asked to you in the exam. In the exam, what kind of question are asked to you? So okay, now I have this question. And here I am using B2H6 THF along with H2O2 OH. Okay, so this is the reagent here. Now the product is going to change entirely. We are going to change the product entirely. What is going to be the product here? No carbocation, no rearrangement of carbocation. Simply break this double bond. Okay, simply break this double bond, and there will be anti-Markovnikov addition. As you know, this has C. It has one hydrogen here. It has two hydrogen here. So negative part, that means OH negative is going to be on the anti-Markovnikov, means negative part on the more number of hydrogen. Okay, so negative part on the more number of hydrogen means you will have OH here and you will have H here. Okay, this is going to be your product in case of diborane. Okay, if you are doing the if your hydrolysis is according to the reagents here, okay? If your hydrolysis is according to diborane THF, if you're doing hydroboration, oxidation, okay? So this step is called hydroboration and this step is called oxidation. Okay, everybody, understood this? Yes? Okay? So no issues in that, right? Let us do the third example here. Third example, very important, that is oxymercuration, demercuration. OMDM. In this case, we are going to use Markovnikov rule. Nothing, no carbocation, no rearrangement. Directly we are going to use Markovnikov addition here. Now this is the main key point of this reaction. We are going to use Markovnikov rules here simply. Okay, let us do the, yes. What are you asking, Sarath? Ma'am, more than enough for boards. Yes, that is actually for NEET and board is going to cover. Okay, board is also in this also, right? So I am actually teaching you for both boards and NEET. Okay, right? Okay, so guys, you have this oxymercuration, demercuration. You have HDOAC twice THF. This is oxymercuration, demercuration. Firstly, there will be mercuration. Mercury will be attached here, right? It will form a mercuration ion. Right? After that, there will be demercuration. Like there is mercuration, HGOAC will attack on this double bond. Okay, it will form a mercurium ion. Right? After that, there will be demercuration. Okay, there will be demercuration. After that, this is the step for demercuration. Right? Demercuration will occur here, and in this case, you will have the formation of alcohol. But that is according to Markovnikov addition. Okay, let us see the mechanism here. This H positive electron deficient, it is going to attack on the electron rich compound here. The double bond, the pi electrons are electron rich, so they are going to attack here. This is electron deficient, this is electron rich. It will form a mercurium ion, right? After that, the water opens the ring. Okay, there is a ring here, the formation of a ring here. Okay, the water along with its lone pair, it is going to attack on this carbon. Okay, that is how you have the attachment of OH group here. Okay, and it will attach here OH. Right? After that, this ring is going to open here and then it will lead to the demercuration in the next step. There will be demercuration reduction by NaHBF4. Okay, so reduction by NaBH4, there will be reduction and you will have the formation of H here. So that is how alcohol is formed according to Markovnikov rule here. Right? So for example, you have the same question here. You have this question. So if there is oxymercuration, demercuration. In this case, what will be is going to be the product here. Okay. In Markovnikov addition, the negative part is going to be on the less number of hydrogens. Okay. Less number of hydrogens. So less number of hydrogen means the OH will be here and H will be attached here. This will be your final product. So in three cases, you have different products. Okay. In all these cases, you will have different products. There can be same products for oxymercuration, demercuration and acid catalyzed hydrolysis, but never for borane and oxymercuration, demercuration. Everybody understood here? Everybody understood here or not? Everybody? Yes? Okay? Perfect. Okay, Sarath, understood that? Yes? Everybody? Now we are going to do from carbonyl compounds. How you are going to form alcohols from carbonyl compounds? For example, you have this carbonyl compound. Okay, so there will be a reducing agent. Always remember this chart that firstly you have, this is for example, you have COH. Then after that you will have alcohol, you will have aldehyde or ketone. The reduction of COH will give rise to aldehyde ketone. The reduction of aldehyde ketone will give rise to alcohol. Okay, this is the chart here. So if we're going to reduce it from aldehyde or ketone, that is going to give us alcohol according to what kind of alcohol you have, what kind of aldehyde you have, right? Okay, so if you have aldehyde, that is going to give us primary alcohol. If you have ketone, that is going to give us secondary alcohol, right? Okay, so what are the catalysts that are used here? The catalyst can be the hydrogenation, what I'm saying. Okay, the catalytic hydrogenation I wanted to say. Okay, the catalytic hydrogenation, right? So you have RCHO, H2PD. Here we'll have the formation of RCH2OH, right? This is the first thing. Simple catalytic hydrogenation using any catalyst, right? And H2, right? Simple catalytic hydrogenation. Next is you have NaBH4. So now these 3-4 reagents for reducing agents are very important for you. So which reducing agent is going to do what kind of work here? So NaBH4, always remember this, only carbonyl group and has no effect on other reducing group. Do not reduce acid or ester. Very, very, very important line. Very, very, very important line. Okay, NaBH4 is going to reduce only carbonyl group. Okay, it is not going to reduce double bond. It is very selective in nature. Okay, it is very selective in nature. And that to carbonyl group of acid or ester, it is not going to reduce that. Okay, so you have this double bond. So this double bond is going to stay intact here. Okay, this double bond is going to stay intact here. This CHO group is going to convert into alcohol. Right? This is a selective reduction here. But in case of LiAlH4, that is actually more strong reducing agent as compared to NaBH4. Right? In this case, it is unselective reducing agent. It is going to reduce double bond. It is going to reduce aldehyde, ketones, ester, carboxylic acid, chlorides, carboxylic acid, even carboxylates to alcohol. It is going to reduce everything into alcohol, right? So it is going to reduce this carboxylic acid, ester also to alcohol. But in case of NaBH4, it is not going to reduce carboxylic acid. It is not going to reduce ester, right? Okay, understood? So now, LiAlH4 is an expensive reagent, so that is why alcohol is formed from acids by converting acid into ester first, and after that doing the catalytic hydrogenation and converting it into alcohol, because it is expensive in nature, so we avoid using it in commercial purposes, right? Okay, next we have from alkyl halides. From alkyl halides, from Grignard's reagent, right? Those two were very important, LiAlH4, NaBH4, right? What is, if you have one question, if I ask you one question here, I'm going to ask one question here, everybody. You have CH3, CH2, CH2, CHO, COO, CH3. Okay, and if you have here LiAlH4 and if you have here NaBH4, NaBH4 is not going to reduce this. Okay, NaBH4 is not going to reduce this ester. Okay, so it will lead to the formation of COO, CH3. It is going to stay as it is. This is CH2, this is CH2, and this is CH2OH. Okay, this is CH2OH. So now if you use LiAlH4, it is going to reduce this ester also. So it will be CH3COH, right? This will be H here. So this is CH2, this is CH2, this is CH2OH. Okay, this is going to be the product here. Okay, in both the cases, the products will be different. Okay, okay. Yes, bacha, bilkul. Right, lucid, bilkul, right. Okay, it is going to reduce everything. But this NaBH4 is a selective, this is unselective reagent. Right, okay. So next we have from alkyl halides. From alkyl halides, you have this alkyl halide, you have this KOH. Always remember one thing. If you have aqueous KOH, that is going to do substitution reaction here that we did in haloalkanes itself, right? If you have alcoholic KOH here, that is going to form alkenes in this case, right? From Grignard reagent, you have CHO, a very simple reaction. Let us see. Where this is usually asked in so many PYQs, you will find this reaction. This is HC, double bond O, and this is H, right? This is RMgX. This is RMgX. What we are going to do here? This is organometallic compound. In organometallic compound, we have, this is partially negative and this is partially positive. This is more electropositive, this is electronegative. So this is also partially positive, right? This is partially negative, right? So what is going to happen here? This R is going to attack here, right? The electrons will jump here and this OA is going to attack here, okay? So you will have the formation of, after hydrolysis, you will have the formation of, this is C, this is OMG, this is X, this is H, this is H, this is R, right? And after hydrolysis, this OMGX is going to convert into OH and this is H and this is H and this is R here. Okay, everybody? Yes? Remember this? Okay, a very simple reaction. A very simple reaction. Okay? Okay, ma'am, will hydrogen in PD reduce acids? Okay, so hydrogen in PD is not going to reduce acids. Okay, that is not going to reduce acids. This is what you are talking about. This is what you are talking about. This is only for aldehydes. Okay, this is only if you want to reduce acids, like this is acid, this is COH. And then you have aldehyde, then you have alcohol. So this hydrogenation is going to reduce acids into aldehyde, not acids into alcohol. It is not a very strong reducing agent, okay, not a very strong reducing agent. You need to know what are the strong reducing agents. So NaBH4 is a good strong reducing agents, right? This is good reducing agents, but it does not reduce acid or ester. Except for that, it does reduce acid halides. Okay, 2 alcohols. This is also a very strong reducing agent, but hydrogenation in catalyst presence is not a very strong reducing agent. That is not a very strong reducing agent. Okay, right? Now we have done this also, right? In this case also, what we are going to do here, this is R, this is C, double bond O, this is H here, this is R, MgX. Okay, so this is going to attack here and this is going to attack here, and you will have, after hydrolysis, you will have the formation of, this is OH, this is H, this is R, this is R. Okay, first you have OMGX here, and after hydrolysis it will get converted into OH. Understood? It will get converted into OH and this will be the formation of secondary alcohol. Right? Next you have, if you have this RCOR. Now in this case you will have the formation of tertiary alcohol. How you will have the formation of tertiary? R, C double bond O, this is R, and here you have R, MgX here. This is going to attack here, this is going to attack here, right? This is going to attack here, and it will lead to the formation of OH here. This is R, this is R, this is R. Okay, you will have the formation of 3-degree alcohol when ketone reacts with Grignard reagent, right? Okay. Next here comes properties of alcohol. Next here comes properties of alcohol. Understood everyone till now? We have done preparation of alcohols. Now we are going to start with properties of alcohol. For properties of alcohol, alcohols are colorless liquids. First thing, colorless liquids with specific smell. They are soluble in water due to H bonding. Okay, H bonding has, water has hydrogen bonding. Alcohol also has hydrogen bonding, for example CH3OH. This is water, this is water. So they are going to have hydrogen bonding here. That is why it is miscible in water, right? And then other organic solvents are partially soluble in other organic solvents. They are liquid in nature, up to 12 carbon. They are liquid in nature. Melting point, boiling point. This is always important for you. Okay, melting point and boiling point is directly proportional to molar mass, inversely proportional to the branching. Everywhere you will have this relation only. In all the chapters you will see this relation. Boiling point of alcohols are higher than equivalent ethers. So why boiling point of alcohols are higher, everybody? This is ether, okay? This is ether. And this is alcohol. And this is alcohol, right? Okay? We are talking about the boiling point here. That means in boiling point, we are going to see the interaction between its molecules. So as this is alcohol and this is another molecule of alcohol, it is going to form hydrogen bond here because this hydrogen is attached to the electron negative atom, right? But this oxygen, there is no hydrogen for it. Let us take the example of this, okay? Let us take this example. Now this hydrogen is not attached to any electronegative atom. There will be no hydrogen bonding, no H bonding. There will be just dipole-dipole interactions. And here in this case, there will be hydrogen bonding. And that is why the boiling point of alcohol is higher than ethers. Understood everyone? That is why boiling point of alcohol is higher than ethers. Right? Okay? Perfect. Increase, degree and chain. Yes, bacha, it is going to, if you are doing the branching, it is going to decrease the boiling point. If I talk about N-butyl, isobutyl, and for example, you have the normal chain and the chain with branching, okay? And the chain with branching here. And you have one chain with branching here. Now, this branch chain is going to have less boiling point as compared to normal, right? More the branching, lesser will be the boiling point. Okay, they are inversely proportional to each other. Now next we have acidic character of alcohol is due to polar nature of OH bond. We have done this polar nature of OH bond. So now this is R, this is O, this is H, right? So this alcohol, as you all know, this oxygen and hydrogen has a very high difference of electronegativity. That is why it is partially negative, this is partially positive. And that is why this is easy to break this bond, and that is why alcohol is acidic in nature. Okay, this is acidic in nature. Electron releasing group, that is CH3, C2H5, decreases the polarity of OH. More is the electron releasing group. Okay, if you have just the alkyl chain is getting like more and more, it is going to donate the electrons. Okay, if it is donating the electron, it is going to decrease that polarity because already there is electrons, they are coming from this side. So this oxygen will not be able to, this oxygen do not want to extract the electrons from the hydrogen because it is already getting electrons from this alkyl chain. If it is getting electron from this alkyl chain, it does not want to extract the electrons from this hydrogen, and that is how it is going to lower down the polarity of OH bond, right? Now you have acidic strength of alcohol. For acidic strength of alcohol, for example, you have CH3, this is branching, this is 3 branching. Here you have one CH3 group, you have 2 CH3, you have 3 CH3 group. It is going to provide the electrons, right? Okay, so the carbocation, the carbon ion here formed, the carbon ion here formed, the carbon ion here formed will be more stable, will be less stable. Okay, it is going to provide the electrons from just one alkyl group. It is going to provide the electrons from 3 alkyl groups. Something is already negative. You are giving the electrons. It is going to destabilize it. Okay, and that is why this is very less acidic as compared to this one, because this is negative. You are providing the electron from just one alkyl group. Okay, everybody? Yes, perfect. Now let us do the reaction with acids. Okay, the reaction with acids. So now let us start that. Reaction with metals. Reaction with active metals, firstly we are going to do that. Okay, so when ROH is reacted with Na, it will have the formation of RONA, very simple reaction. Okay, just see, first the very simple thing that is going to happen here. This is going to form the salt here. Okay, this is going to form, we all know, if there is acid and we are going to react it with a metal. Okay, we are going to react it with a metal. So what it is going to form? It is going to form a salt and H2. Similar way this happened. This is acidic in nature and this is metal. And if this is acidic in nature, it is going to extract this H2, this H from here, right? Because this is acidic in nature, it is going to form H2 and the salt of this compound that is given to us. Right? If there is acid, it will form the salt of acid. Now we have alcohol, it will form the salt of alcohol here. Right? In this case, you have tert-butyl alcohol. In tert-butyl alcohol, you have this. Now very simple thing, you have Al. Right? In this Al, you have Al has +3 valency. Right? With using +3 valency, it is going to form aluminium tert-buto-oxide. Okay? It is going to form aluminium tert-buto-oxide. Right? Because it has 3 valency. It has just 1 valency. Here it has 3 valency. So the salt that it is going to form will be with 3 valencies. Okay, will be with 3 valencies. Now next we have esterification. For esterification reaction, any of this with alcohol in acidic condition will give rise to ester. Right? You have carboxylic acid or acid chloride or acid anhydride. Anything here with alcohol is going to form ester in this case. In acidic condition, you will have directly the formation of ester. In case of basic, you will have the formation of, a salt here, right? You will have the formation of salt here. So let us say acid chloride with that is this with ROH in presence of pyridine, you will have the formation of RCOR. And in case of acid anhydride, for example, this is a very simple reaction. Let us see. This is RC double bond O. For example, we are talking about acid, and this is ROH. Okay, this is ROH. Right? So just take it here. This is negative. This is positive. This is positive. This is positive. This is negative. Right? Okay. Simply, you will just equate this, and you will have RC double bond O. This is O, and this is positive here, right? And this H will go along with this. This is H2O. Okay, you will have the formation of ester here. First thing. Next thing is you will have, if you have acid anhydride, that is you have CH3, C double bond O, O, C double bond O, CH3 along with CH3OH. So in this case, it is going to form again, that is negative, this is positive, right? This is positive, this is negative. It is going to form the product here, CH3, this is C double bond O, right? This is CH3, this is C double bond O, right? This is O. This is oxygen, oxygen, right? The positive here is CH3. It will attach here, right? And it will lead to the formation of this positive. This is positive part, that is C double bond O, CH3. And the negative part here, that is OH. Okay, so that is going to form acid and ester. Okay, it is going to form acid and ester, right? It is going to form ester and acid in case of acid anhydride. Okay guys, understood this? How we are forming this? If you have acid chloride, very simple reaction. You have RC double bond O. You don't need to cram anything here, right? You don't need to cram anything here. You have ROH, right? Simply put positive, negative here. Very simple. Positive, negative. So this is negative, this is positive, right? This is positive, this is negative. So in this case, always remember we are breaking this bond, the CO bond of ROH, right? So in this case, you have RC double bond O positive. The positive part, wait. Okay, wait. This is negative, positive, yeah. So it will be negative, positive only. This will be negative, this will be positive, this will be this will be O and this will be H. Okay, there will be difference here. This is the positive part, this is the negative part. So it will be RC double bond O, and this is negative part. It is going to pull the positive part here, right? This is positive, this is more electronegative, this will be negative here. This is more electronegative, this is positive, right? So it will be negative and positive here. So this is positive, this is the negative part, that is OR, and this is HCl, right? Okay, so it is going to form ester and HCl, right? So these are a very simple reaction that we are going to do in this case. We also learn about this later, right? So reaction with acid, that is you have this, firstly you have this acid, it will be protonated, right? After protonation it will leave, it will go out with this, it will pull out the electron, the oxygen is going to pull out the electron, this is ROH. So it is going to form an intermediate here. You don't need to remember the whole mechanism, but just go through this once, This is R, this is C, this is OH, right? The OH is again going to, this is going to leave here, right? This is OH, this pi bond is going to attack on this electrons, because this oxygen is now electron deficient. So it is going to pull the electrons from this pi bond, right? This is electron deficient, it is going to pull the electron from this pi bond. After pulling the electron, it will have the OH here, right? Now this has only 3 bonds. To complete its electron deficiency, this ROH is going to attack here. This ROH is going to attach here. Okay, so this ROH is going to attach here, and will from the oxygen this is going to attach here. So after that, the oxygen of ROH is now electron deficient, because it has shared the electrons with this carbon. So now it has 3 bonds, it is electron deficient, it has shared the electrons, it will take away the electrons from somewhere, right? So because hydrogen is weak, so So it will take away the electrons from hydrogen, and after that you will have the formation of this intermediate. And now from this intermediate, again this is H2, right? This is H2. So there will be this will actually take away the electrons, and this hydrogen will be shifted on this side. The hydrogen will be shifted on this side. Now this oxygen is going to take electrons from this, and it will leave from here, and you will have the formation of ester after deprotonation from this side. Right? Simple, 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 very simple. Okay, everybody? Yes. What happened? What happened? Just break the OH bond? Yes. Bacha, we are going to do the questions. Don't worry. We are going to do the questions, okay? We are going to solve the questions. This is a very big chapter, okay? I am going to complete the questions. Just be patient, okay? Just be patient here. So, for Lucas test, next we have Lucas test, that is the distinguished test of 1 degree, 2 degree, 3 degree alcohol. Here we use anhydrous ZnCl2 along with HCl concentrated. In this case, 1 degree, 2 degree, 3 degree alcohol are differentiated. For 3 degree alcohol, the turbidity appears quickly. For 2 degree alcohol, it takes about 5 minutes. And for 1 degree alcohol, it takes about 30 to 40 minutes when we heat it, or we can say no turbidity is observed in this case, okay? No turbidity is observed in this case, and it is observed only in case of heating. Even after heating, it is observed after 30 to 40 minutes, right? So that is a differentiation of 1 degree, 2 degree, 3 degree alcohol. So this is now the reaction with halogen acids. If you have halogen acid, that is HX, right? You have this ROH. So it is going to form RX and H2. How it is going to form RH and H2? So this is negative, right? This is negative, this is positive. This is negative, this is positive. Now this negative is going to attack here, and the OH will attack on this side. So it will release H2O. Okay, just replace positive, negative, positive, negative. Just replace that, you will have your answer. Now let us see the proper mechanism of this. So for proper mechanism, let us see primary alcohols react via SN2 mechanisms, while secondary and tertiary alcohol react via SN1 mechanism. So have we done this reaction, everybody? Have we done this reaction in haloalkanes and haloarenes? Have we done this reaction? Right? We have done this reaction in haloalkanes and haloarenes in detail. Right? We have completed this reaction in detail. Order of reactivity of halogen acid is HI, HBr, HCl. Why so? Because HI has more, the size is bigger, so the length will be more, and that is why it will be easy to break HI bond, right? It will be easy to break this bond. Reactivity of alcohol is tertiary, secondary, and then primary. Okay, this is towards SN2 mechanism. Okay, sorry, this is towards SN1 mechanism, right? According to the mechanism, there is the reactivity order, right? There is the reactivity order. So reaction with halogen acids, this is the reaction where transition state is formed. In this case, they are showing SN2 mechanism. For SN2 mechanism, transition state is formed here, right? And then you will have the formation of your haloalkane, right? In the SN1 mechanism, here you will have the formation of carbocation in this case. Carbocation is formed, that is rate determining step, and hence the order is 3 degree, then 2 degree, then you have 1 degree, right, for SN1 mechanism, right? Okay, we have already done this, and very good, we have already done this in haloalkanes and haloarenes. Next we have reaction with PCl3. Again we have done this. Okay, this reaction is again repeated. ROH with PCl3, you have RCl and H3PO3 repeated. Okay, next this is the mechanism. We have already done this. This mechanism of ROH, you have ROH, you have PCl3. So how it will be formed? This lone pair is going to attack on the phosphorus, that is electron deficient. The octet is not completed here, right? So it will take away the chlorine is going to leave from this side, because it cannot handle more than 3 electrons, more than 3 bonds here. So you will have the formation of this protonated alkyl dichlorophosphate here, and after that after that the second step will be, it is going to by SN2 mechanism, it is going to form RCH2Cl. Okay, RCH2Cl, very simple reaction. The mechanism is not like asked here. You just need to remember this one, that is no Rearrangement, no carbocation rearrangement, no carbocation is formed in this case. Right, this is SN2 mechanism. Okay, this is why SN2 mechanism, transition state is formed here. Right, simple transition state is formed in this case. Right, with the oxidation of alcohol. So now next step is oxidation of alcohol. Next step is oxidation of alcohol. For that, let us see what are the bonds that can cleave, right? Oxidation of alcohol involves the formation of carbon oxygen double bond. You have carbon oxygen double bond with cleavage of OH and CH bond. You have the cleavage of this bond and this bond, okay? After that, you will have the formation of different oxidation products. Oxidation of alcohol depend on oxidizing agent. So it depends on the oxidizing agent. How does it depend on the oxidizing agent? So oxidation of alcohol is a very important concept, okay? What is the reagent? According to that, you have to answer what is the question, okay? What is the product? According to the reagent. For example, if we are talking about strong oxidizing agent, strong oxidizing agents, let us see how does strong oxidizing agent react, okay? You have RCH2, and this is OH, right? Okay, so how strong oxidizing agent react? Okay, this is RCH2, this is secondary alcohol, this is CH, this is R, this is CH2, this is OH, right? And for tertiary, you have R, C, this is R, this is OH, right? So if you have strong oxidizing agent, for strong oxidizing agents, we are going to do this. Then for mild oxidizing agents, we are going to do this, right? For strong oxidizing agent, a simple reaction is going to occur here. Okay, for strong oxidizing agent, this is RC, this is OH, this is going to be the OH, and this is OH, right? Okay, this is strong oxidizing agent. So it is going to take away this H2O and will lead to the formation of this acid. It will lead to the formation of this acid here, right? With the strong oxidizing agent for 2 degree, it is going to form, this is R, this is C, this is R, right? This is actually RCH, this is R, okay? 1, 2, 3, 4, right? Okay, so this is going to form here, this is OH, and this is OH, okay? So it is going to take away this OH and this, okay? If you have two OH on the same carbon, they are not stable, and that is why it is going to form here C double bond, okay? It is going to form ketone in this case, right? It is going to form ketone in this case. And with 3 degree alcohol, nothing is going to happen here. Okay, no reaction is going to take place in this case, right? Okay, no reaction is going to take place in this case. Now, if you have mild oxidizing agents, simple reaction that is going to take place in this case. Okay, you have R, this is C, this is H, this is OH, and this is OH. Okay, so what is going to happen here? This OH is going to replace here, and you will have the formation of aldehyde in this case, right? In this case, this is C, this is R, and this is OH, and this is OH. So it is going to form ketone in this case, right? In this case, it will have no reaction. Okay, it will have no reaction, right? Okay, so that is why it is very important, because the products are entirely different. For 1 degree, for primary alcohol, it is oxidized to acetic acid. Okay, it is oxidized to carboxylic acid. This is for mild and this is for strong oxidizing agent, right? Okay, and if we talk about 2 degree alcohol, it is going to convert it into ketone. Okay, it is going to convert it into ketone. For 3 degree alcohol, there will be no reaction. For 3 degree alcohol, there will be no reaction that we have done in this case. Okay, this is aldehyde. This is carboxylic acid. This is carboxylic acid, right? And this is ketone. And this is no reaction, right? In this case, you have aldehyde, you have ketone, and you have no reaction in this case, right? There is one another concept here, that is if you have copper at 300 degrees Celsius, okay? At 300 degrees Celsius you have copper. In this case, aldehyde, if you have 1 degree alcohol, if you have 1 degree alcohol, if you have 2 degree alcohol, if you have 3 degree alcohol, the product is going to be entirely different in this case. What is the reason? The product is going to be entirely different. What is the reason? For 1 degree alcohol, you are going to have aldehyde. For 2 degree, it is going to behave as a mild oxidizing agent for 1 degree and 2 degree, okay? This is going to have ketone. But for 3 degree, it is going to have alkene, and that is why this alkene part is very important. It is going to have alkene. So these questions are asked in your examinations. Okay, these kind of questions are asked in your examination, that for copper at 3 degree 100 degrees Celsius, you have 1 degree to aldehyde, 2 degree to ketone, and 3 degree to alkene. Right? Okay, everybody. So now let us see this. This is for strong oxidizing agent, right? We have done this also. Again, any strong oxidizing agent, the answer will be same. Any strong oxidizing agent, you have 1 degree to carboxylic acid, 2 degree to ketone, 3 degree have no reaction, okay? Similarly, it will have no reaction here, right? With Jones reagent, if you have Jones reagent, which is a strong oxidizing agent, that is actually what is Jones reagent, everybody? This is Cr2, this is CrO3 in acetic acid, okay? Sulfuric acid dissolved in a mixture of acetone and water. If you have sulfuric acid here, if you have H2SO4 dissolved in acetone, okay, that is called Jones reagent, which is a strong oxidizing agent. But for example, they have done a tricky part here. That Jones reagent is CrO3 in presence of CH3COH. Now acetic acid is a weak acid, okay, as compared to H2SO4. And in this case, you have acetone here, okay? You have acetone here. So in this case, this is nothing but this is weak oxidizing agent, or this is mild oxidizing agent. This is mild oxidizing agent. What is the reason? Because the acid here is strong. The acid here is weak. If you are not given anything, they are simply written Jones reagent, you will consider it as strong oxidizing agent. If they have mentioned it, H2SO4, you will consider it as strong oxidizing agent. If they have not mentioned H2SO4, you will consider it as weak oxidizing agent. Understood this? Generally, we think that Jones reagent is strong oxidizing agents only if they have not mentioned anything. But if they have specially mentioned the acid taken there, then you need to have a check on that. If the acid is weak, that will be mild oxidizing agent. Okay? Right? So, it will also behave in a similar way. In case of primary, you will have acid. In case of secondary, you will have ketone. In this case, tertiary will have no reaction. Okay, what is PCC and PDC? Everybody, what is PCC and PDC? Everybody in the chat box. PCC, pyridinium chlorochromate. It is equivalent mixture of CrO3, HCl and pyridine. Okay, this is equivalent. PCC, pyridinium dichlorochromate. And what is PDC, everybody? What is PDC? This is the structure. The PDC, you have to remember the name here. Okay, you have to remember the name here. You don't need to remember this, okay? You don't need to remember this. You just need to remember the name in this case, okay? PCC, pyridinium dichlorochromate. And what is it? It has basically, this is pyridine, okay? You have this compound, okay? Pyridine dichlorochromate, right? That's it. Wait. Yes. Okay. Yes. So now, these are weak, or you say mild oxidizing agent. These are mild oxidizing agents, right? These are mild oxidizing agents. So in this case, the products will be of mild oxidizing agents, right? So it will have, if you have this 1 degree, you will have the formation of aldehyde. If you have 2 degree, you will have the formation of ketone. You will have the formation of ketone here. Right? That's it. For example, in this case, this is 2 degree, okay? This is 2 degree. And this is 1 degree. And that is why here you have the formation of CHO and here you have the formation of double bond O. That's it. Okay? Yes. Now, next is copper with heat. Now, this is important. In this case, with primary, you have aldehyde. With secondary, you have ketone. With tertiary, you have the formation of alkene. With tertiary, you have the formation of alkene in this case. Right? I have already mentioned it in these 3 paragraphs. Okay? In these 3 slides. I have already mentioned, you just need to remember this one. Okay? This one, then this one, and then this one. Okay? Then the list of mild, weak and strong. Okay? This is strong oxidizing agent. You write it here. KMNO4, K2Cr2O7, and you have Jones reagent. And with mild oxidizing agents, you have PCC, PDC. Right? With Cu, 300 degrees Celsius. Right? You have different products here. Right? These are the things that you need to remember for strong and weak oxidizing agents. Right? Everybody in the chat box understood this. Now next is with MnO2. Very important. So see, there's some different oxidizing agents. Like copper was behaving very differently. So similarly, this is behaving very differently. This MnO2 selectively oxidizes the OH group of allylic and benzylic alcohols to aldehyde and ketones respectively. Right? It just selectively oxidizes what? Allylic and benzylic 1 degree and 2 degree alcohols to aldehydes and ketones respectively. Right? Okay, everybody. For example, this is 1 degree allylic alcohol. In this case, it is going to reduce this selectively to aldehyde. Okay, it is going to reduce, if this is 2 degree, this is 2 degree benzylic. Okay, this is 2 degree benzylic. In this case, it is going to selectively reduce it to C6H5C double bond of CH3. Right, everybody? Yes. So let us do a question based on this. Let me do a question for you. For example, you have CH2. This is C. Okay, I am going to draw the hydrogen after this. This is OH. This is C. This is CH2OH. Right? Okay. Okay, so this is double bond, and this is C, this is OH. Yes. Okay. Everybody in the chat box, everybody, let us solve this question. This is CH2, this is CH. We also need to know if you are able to understand or not. Okay. Because just cramming things is not going to work. Okay. 2, 3, 4. We will have here just 1 hydrogen. 4. And this is H here. Right. Okay. Perfect. So now let us solve this. If you have, I'll draw it one by one. If you have strong oxidizing agent, what will be the answer? For strong oxidizing agent, what will be the answer to this? What will be the answer? The answer will be, it is the 1 degree, it will convert 1 degree to CH3. This 1 degree will be getting converted into CHO. Okay, this is CHO, and this will be 2 degree. This is 1 degree. This is 2 degree. Okay, this is 2 degree. We're going to convert this 2 degree into double bond O. Okay, this is going to get converted into double bond O, right? And if you have, this is CH2, this is CH, this is double bond, this is CH, this is CH2. And this is also 1 degree, this is also 1 degree. So it is going to convert it into CH, and this is CHO, right? This is CHO. This is first thing. If you have mild oxidizing agent, what is going to be the answer here? For mild, this is mild. I have done this for mild oxidizing agent, right? This is mild oxidizing agent. Let us do this for strong oxidizing agent. For strong oxidizing agent, this will be getting converted into COH. 2 degree into double bond O. This is CH2. This is CH. This is double bond. This is CH. Okay, and this is COOH. Right? If you have MnO2, the product will be different in this case. It will have no effect on this alcohol. It will have just effect on this allylic alcohol, because this is 1 degree allylic alcohol. So it will selectively oxidize this alcohol only. So you will have the formation of this COH, this is CH2OH, and here you will have CH2. This is H, this is CH2, this is CH2CH double bond CH. You will have CH2. Now this is 1 degree, so it will be oxidized to aldehyde. If it is 2 degree, it will be oxidized to ketone, right? So this will be oxidized to the CH, this is CH2. So this is aldehyde, right? Okay, everybody? Everybody in the chat section, clear with this? With mild oxidizing agent, with strong oxidizing agent, with MnO2, the product is going to be entirely different. Right, the product is going to be entirely different in this case, right? You have to know what is the reagent here, right? Okay, everybody, shall we move ahead? Shall we move ahead, everybody in the chat box? Shall we move ahead, everybody in the chat box? Yes, everybody. Shall we move ahead? Okay, perfect. Any problem till now? Any problem, bacha, till now? Any issues, any problem, anything that you're not able to understand? Everybody, anything, any problem that you are not able to understand? Yes? Yes, miss? Okay, perfect, perfect, everybody, perfect. So now let us do the dehydration reaction, okay? The dehydration reaction. For dehydration reaction, you can have dehydrating agents such as H2SO4, H3PO4, or any catalyst such as anhydrous alumina. All these are dehydrating agents, right? So primary alcohol are heated with concentrated this and this and this. They undergo intramolecular dehydration to form alkenes. This is this, and it will lead to the formation of alkene here, right? It will lead to the formation of alkene here, right? You have 85% H2SO4. This will lead to the formation of alkene in this case. This will lead to the formation of alkene in this case. 3 degree ease of dehydration of alcohol. What is the ease? 3 degree is going to be the fastest that is going to form alkene, okay? 3 degree, then 2 degree, then 1 degree alcohol. That is the ease of dehydration in this case, right? Simple dehydration reaction. So what is the mechanism here? For mechanism, just always remember, here you have the formation of, wait, yes, okay? Here you have the formation of carbocation in this case, okay? That is the slowest step. And that is why ease of dehydration was 3 degree, then 2 degree, then 1 degree, okay? Because the intermediate that is formed here is carbocation. So always remember these few steps: slow step, rate determining step, and carbocation rearrangement is possible in this case, right? So ease of dehydration of alcohol will be this, right? The rearrangement of carbocation, you have to see that. Only then you will form the alkene in this case. Everybody, is this clear to you all? Is this clear to you all? And also, the alkene that is formed here is according to the Sedgwick rule, okay? According to Sedgwick rule, this is your NEET, I think 2020 question only, right? NEET 2021, maybe 2020, Sedgwick rule. Sedgwick rule says this: according to hyperconjugation, you have to know the answer, right? For example, out of this and this, which is major product here? The major product that is highly substituted, right? That means it has 6 alpha hydrogen, and in this case, it has 2 alpha hydrogens, right? So it will have this will be the major product and this will be the minor product in this case. Okay, everybody? Yes? Okay, perfect, perfect. So now next we have, so what is this? This is also dehydrating agent. Yes, always remember, students usually forget about this Al2O3. Alumina, I also told you, H3PO3, alumina. All these are P2O5. These are the dehydrating agents, okay? So these are also going to form dehydrating product, that is alkene in this case. The vapor of alcohol passed over this form alkene, okay? Reaction with P2O5 and then heat also forms alkene in this case, right? Okay, so primary alcohol at this in presence of excess of either this form, wait, the primary alcohol heated at 413 in the presence of excess of alcohol, ether will form. Okay, wait. Okay, so now they are saying that if you have one primary alcohol, okay, you have one primary alcohol, and at 413 you are heating it at 413 Kelvin in the presence of excess of alcohol is formed, so ether is going to form. Now this is also very important. At 413 Kelvin, okay, at 413 Kelvin you are going to form ether in this case, okay, you are going to form ether in this case, and in this case, wait. And this case, you heated it at 440 Kelvin. You had the formation of alkene in this case, right? If you have some dehydrating agent, so for example, you do not have any dehydrating agent. And that is heated at 413 Kelvin, that is going to form ether, okay, because this is electron rich, okay, this is going to attack on this, right, there will be protonation, and after that this is going to attack on this carbon, and this will lead to the formation of ether here, okay everybody, this is going to the formation of ether here. This is also your PYQ, that at 413 Kelvin, this alcohol is going to form ether, okay, this alcohol is going to form ether here, right? Okay, next we have the properties of preparation of phenol. Now let us do phenol here, okay, half of the reaction is completed, half of the chapter is completed in this case, and we are left with half chapter. Okay, perfect, I'll slow down from here, okay? Okay, I'm fast. Okay, I'll slow down. Okay, yes. I thought, okay, I'll slow down. No worries. So you promise me you will be here, right? You will be here. Okay, because if I slow down, the lecture is going to stretch. So in that case, you have to promise me, even if the lecture is going to stretch, you have to be here, right? Okay? Okay, everybody? Yes, very good evening, bacha. Very good evening. So, okay, now let us do preparation of phenol. There are few processes, very important processes. First is Dow's process. We have done this process, everybody. Have we done this process in alcohol phenol, in haloalkenes and haloarenes? What was the intermediate that was formed here? Everybody in the chat box. What was the intermediate? The intermediate that was formed was benzene. Okay, benzene was the intermediate. From chlorobenzene we used to form this phenol, right? The conditions were very drastic. The conditions were at 300 degrees Celsius at high pressure, okay, under very high pressure at almost 200 to 300 atmospheric, at around 673 Kelvin, right? We have the temperature, right? But tell me one thing, if I am using this is the formation, okay? You have firstly the formation of the mechanism. We have already done the mechanism, right? So tell me one thing that we did in haloalkenes. Now you have this phenol, right? You have this chlorophenol, right? You have NO2 group at ortho and para position. At ortho and para position, the condition will be very mild. Just warm it and you will have the formation of picric acid. So if NO2 group at ortho and para position, conditions are mild, okay? Conditions are mild because at ortho and para position you have negative charge there, and because of electron withdrawing group it is going to extract that negative charge at ortho and para position, and that is how at meta position, if you have electron withdrawing group at meta position, no effect is going to occur in that case. Okay, in that case, no effect is going to occur in that case. Okay, guys? Yes. No, I have not done my dinner. I'll do after the class. Okay, I'll do that after the class. Next is Cumene process. Okay, next is Cumene process. For Cumene process, a very important process for your PYQs. Very important process for your PYQ. You have already done this. You will see every year. If you analyze last 5-year question paper, this question has been asked every year. Okay, every year. Right? So this is actually trending right now. Right? You have reels trending. This is trending right now. So this is phenol. In this case, isopropyl benzene is called cumene. Right? So first you will have the formation of cumene either by any process. You can have that by Friedel-Crafts alkylation. By this process where you have this H positive, it is going to form this carbocation, that is CH. This is CH3 and this is positive. This carbocation is going to attack here and you will have the formation of isopropyl benzene. And after the formation of isopropyl benzene, in the presence of air, that 2 oxygen, it will have a peroxide linkage here. Okay, this 2 oxygen is going to place in between the CH bond. Okay, in between this CH bond, you have this C, this is CH3, this is CH3, this is H, right? And this is benzene group, right? And this H is going to replace by OO and H, right? This is going to be the formation here. Now this product is also very important, that is cumene hydroperoxide. Cumene hydroperoxide. So now in this case, the byproducts are also very important, that is acetone and phenol. Right? After the hydrolysis, here it is going to form, this whole thing is going to form acetone. And this one is going to attach here, that is phenol. Okay? So this whole process, the byproducts are also very important, that is phenol and acetone. Now let us see the next process, that is alkali fusion of sulfonates. For alkali fusion of sulfonates, very simple, that is you have H2SO4. First it is formed SO3H here, right? It is going to form here. You can also use oleum here, right? After that NaOH, you will have the formation of SO3Na here. Then after that you will have NaOH fused here. You will have formation of sodium phenoxide. Okay. And after that hydrolysis, you will have the formation of phenol here. So basically this whole is not that important for you. You just need to know H2SO4. After that NaOH fusion, you will have the formation of phenol. Just 3 things, that is H2SO4, fuming, or you can say oleum. Okay, fuming or oleum. Then you have NaOH fused. Then third part is you have hydrolysis here, right? This is going to give you phenol, right? Okay. Out of this, dose process and dose process is important. Cumene process is important. This is not a very important process, right? But still that is mentioned in your NCERT. Right, next we have from diazonium salt. We are going to do this in all the amines chapter, all the amines reactions. This is NLE. From NLE, NaNO3 and HCl 0 to 5 degrees Celsius. You will have the formation of diazonium salt here. This N2 is very unstable. It is going to release by adding just water and warming it. You are going to have phenol N2 and Cl, because N2 is very unstable in this case. And you will have the formation of phenol in this case. And this from this diazonium salt, you have so many reactions that are asked in your NEET examination, that are in your amines chapter. Okay, that is in your amines chapter. Next we have from decarboxylation. From decarboxyl sodium silicate with soda lime. Now you have this, right? Okay, in this case, this CONA from decarboxyl, this is soda lime decarboxylation. Okay, this is soda lime decarboxylation. Soda lime decarboxylation. In this case, very simple thing, this whole thing is going to get replaced. Okay, this whole thing. Okay, you'll have the elimination of CO2 here. Okay, and this Na will go from this side, and you will have this will be replaced by hydrogen here, and here you will have the formation of phenol. Okay, here you will have the formation of phenol, right? Then you have soda lime decarboxylation. We have done this in hydrocarbons. Okay, we have done this in detail in hydrocarbons. Next we have phenoxide. Okay, acidity of phenol. Next we have acidity of phenol. So phenoxide ion, we say what is acidic nature? It is to lose H positive. After losing H positive, we will have the formation of this phenoxide ion. As you know, this is resonance stabilized, right? This is resonance stabilized. Wait, if I have any structures here. Wait, let me see if we have any structures here. No, we don't have any structures here. Don't worry. I'll just tell you what is the factor why it is stabilized. This electron will jump here. The electrons will be shifted here, and hence you will have the formation of, this will be negative here, double bond O, this will be positive, double bond, double bond. Again, this electron will jump here, the electrons will jump here, it will lead to the formation of resonating structures. And that is why this is stabilized by resonance. By resonance. And as you all know, to predict the acidity, we always say if the carbon ion formed after losing H positive is stable, then we say this is a good acid, and that is why phenol has a good acidic nature, right? So let us see how we can enhance or decrease the acidity of phenols. So if we have electron withdrawing group, okay, if this is, we have any electron, this is phenol, this is the phenoxide ion. If you have any electron withdrawing group, okay, if you have any electron withdrawing group, that is going to pull the electron. If something is negative, you are taking away the electron. That means you are making it more stable. So electron withdrawing group enhances this enhances the acidic nature of phenol. Okay, electron withdrawing group, like what are the electron withdrawing group? Electron withdrawing group are those where everybody. What are the electron withdrawing groups? For example, this is G and this is directly attached to a group, that is B. Okay, now B is more electronegative than G. So now it will take away the electron. Okay, it is electron withdrawing. That is the reason. Now, what is electron donating? If you have a group G that has lone pair of electron, that is electron donating. Okay, that is electron donating group. Right? So electron donating group, something is already negative. You are actually providing the electron. If something is electron donating group, right? You are providing the electron. You are making it destabilized, right? So it decreases the stability, decreases the acidic strength of phenol. Right? Okay, everybody? Yes. This effect is more pronounced when such a group is present at ortho and para position. What is the reason behind that? What is the reason? Anybody? Can you tell me what is the reason behind that? Why ortho and para position that effect is more pronounced? What is the reason behind that? Anybody? Okay? Anybody? What is the reason? Because when you draw the resonating structures, you see there is negative on ortho and para position. Okay, there is negative on ortho and para position. Other resonating structure will also have, for example, this is the electron is going to jump here. You will have the negative charge on para position. So you have ortho and para is negative position. That is why if you have electron withdrawing group in ortho and para position, that is going to have a good effect. That is going to decrease the electron density, right? And that is going to make the carbon ion more stable, right? Okay, everybody? Yes. Perfect. Now let us see some reactions of phenols. Okay, some reactions of phenols. So everybody, till now, any question, any query, metaposition density is decreased. Very good. Till now, any problem, everybody? Any problem? Shall we move ahead? So now you have bromination. For bromination, in case of CS2 and in case of water, the products are entirely different. So if you have CS2, for the example here it is written at ortho and para directing. Wait. Okay. So when the reaction is carried out in solvents with low polarity, this line is very important. With low polarity, if that is carried out with solvents in low polarity such as CHCl3, CS2, in that case, it will lead to the formation of different products, that is ortho and para products. And now tell me why everywhere you will see ortho and para products. What is the reason? The reason is there is a negative charge on ortho and para positions, right? There is a negative charge on ortho and para position here. As you can see, negative charge here. So the electrophile is going to attack at ortho and para position. And that is why we have ortho and para substituted products in this case. Right? So for bromination, if you carry out in the presence of solvents like CS2, right? CCl3. In solvents like CH2CHCl3, in these solvents, you will have the formation of two different products, that is ortho and para. And para is always major because of the symmetry, right? Because of the symmetry, right? Next we have bromination. If you have bromination, this is simple, very simple electrophilic substitution reaction mechanism. Okay, very simple electrophilic substitution mechanism. You will generate an electrophile here. It will have the formation of ortho and para product. Okay. So next is, if you have bromination, if you do the bromination in presence of a polar solvent, that is water, okay, with high polarity. In this case, you will have one product, that is ortho and para product, okay, ortho para product, just one product, that is 2,4,6-tribromophenol, okay, just one product, that is ortho para product. Both positions will be substituted, right? Next we have nitration. So now nitration also have two different things. Firstly, if you have dilute HNO3, and if you have dilute mixture, in case of dilute HNO3, you will have different ortho and para products. Okay, you will have different ortho and para products. Like, okay, bacha. Thank you so much. Yeah. Thank you, bacha. Thank you. Please tell them to study, right? I can't do anything. I can only teach you, no? I can only teach you. Okay. So now if you have dilute HNO3, in case of dilute, you have ortho and para product that are entirely different. Okay. There's no different ortho product, different para product. But now, if you have, wait, concentrated HNO3. If you have concentrated, in that case, there will be one product, that is 2,4,6-nitrophenol. Okay, you will have one product, that is one product which will be ortho and para substituted in case of concentrated HNO3, right? And also then we see one more thing, that is, we have done this in purification, right? We have done this in purification. Now, which is more stable here? Which is the major product here? Now, in this case, this is going to be the major product, okay? This is going to be the major and this is going to be the minor product. What is the reason behind that? Why this is major and this is minor product? This is major because of hydrogen bonding here, right? And also, next, that is, this is actually steam distilled product, okay? We can separate these two because this is steam volatile. This is steam volatile having low boiling point because there is intramolecular hydrogen bonding. There is intramolecular hydrogen bonding. The molecule is actually bonded to its own atom with hydrogen bonding. So it does not have hydrogen bond with the other molecule. And that is why this is having low boiling point, because the intramolecular interactions are stronger as compared to intermolecular interaction, and that is why it has low boiling point, and that is why it is steam volatile, right? So this is also a question from your purification chapter, right? Okay, next is sulfonation. For sulfonation, things are simpler here. For sulfonation at 25 degree, phenol gives ortho hydroxyphenol. So now let us see. So you have this phenol at 20 to 25 degrees Celsius, you have ortho product. At 100 degrees Celsius, you have para product here, right? At ortho product, you will have 20 to 25 degree. With para product, you will have 100 degrees Celsius in this case, right? Okay. Next is formation of picric acid by sulfonation. This is used in conversion reactions, okay? So how to form picric acid for sulfonation? The path is sulfonation. So let us see how to form that, okay? You have, this is the product, formation of picric acid. What do you do here? After the formation of these two products, right? Okay, these two products, you will have, after sulfonation, you have ortho and para product. Now after that, concentrated HNO3, that is nitric acid, nitrating mixture. After this, you will have, if you have these two products, okay? Now, after adding concentrated HNO3, you will have the formation of picric acid. You will have the formation of picric acid, right? Okay, this can be asked to you in case of conversions. Next is Kolbe's reaction. So now what is Kolbe's reaction? Again, a very important reaction. Kolbe's reaction and Reimer-Tiemann reaction. In Kolbe's reaction, you will have the formation of salicylic acid. Okay, you will have the formation of, wait, you will have the formation of salicylic acid in this case. In the case, you will have the formation of salicylic acid. In Kolbe's reaction, the reagents that are used here is CO2, H positive, right? Firstly, NaOH, you will have the formation of sodium phenoxide. After sodium phenoxide, you will use CO2 that is acting as an electrophile here, that is going to act as an electrophile here, and that is going to form salicylic acid. The mechanism here is very important. The mechanism for Kolbe's reaction and Reimer-Tiemann reaction are very important mechanisms, okay? So you have this phenol, and now this phenol, if you add base here, base is going to abstract H positive, right? Base is going to abstract H positive. It is going to form phenoxide ion here. After the rearrangement, after the resonance of phenoxide ion, will show resonance here. After this, you will have a negative charge at ortho position because of resonance, right? At ortho position, now this is acting as an electrophile, right? This is electron deficient, right? This is electrophile, CO2. Now this CO2 carbon is going to attack here, okay? This electron rich species is going to attack on the carbon of CO2, and the electrons are going to leave from this side, right? You will have a negative here. Here you will have the formation of this kind of product, right? This kind of product will be formed here. Now, after this, you have this H positive. Now this oxygen has double bond, right? As negative charge is more stable here, it is going to pull the electron here, okay? It is going to pull the electrons. It is going to give the electrons here to complete the, to complete the tetravalency of the carbon. And now you will have the formation of this H positive is going to transfer intramolecularly, and you will have the formation of this salicylate ion. Now you have this one. Now what about this? After that, you will have there are 2-3 processes. Usually what students do, they justly add, if mechanism is asked in board examination, then you need to know this step, okay? If that is in NEET, you also need to know that step, because Na positive is attacked firstly. You can't directly add H positive here. H positive is not directly added here, right? Firstly you add Na, right? Na is attacked here. After that you have sodium salicylate, okay? Sodium salicylate here. And after the acidification, you will have the formation of salicylic acid. Okay, everybody? Yes? Okay. Okay, everybody? Perfect. Next we have Reimer-Tiemann reaction. In this case, the intermediate formed is carbene. Okay, that is the key point here. And here you will have the formation of salicylic aldehyde. Okay, you will have the formation of salicylic aldehyde. Here CHCl3 aqueous NaOH is used here. You will have the formation of dichlorocarbene here. And if you use CCl4 here, you will have the formation of salicylic acid. Okay, salicylic acid here. Salicylic acid here. If you use CCl4 here, right? Okay, let us see the mechanism. Again, you will have the electrophile is dichlorocarbene. This is the important step here. This is the important step here. What is the intermediate here, right? Firstly, you will have the first step, that is not the rate determining step, right? CHCl3 is going to, this is the base, okay? This is from the base. The base is going to abstract proton, okay? It is going to abstract proton from CHCl3. And here you will have the formation of this one, right? Again, it is going to lose one Cl negative, right? And then you will have the formation of CCl2, that is our intermediate. That is our intermediate, or you can say that is our electrophile, okay? That is our electrophile, okay? Now this is formed here. Now this electrophile is generated here. In Kolbe's reaction, you had CO2. In this case, you have CCl2. That is the electrophile, okay? You will have electrophile is dichloro. Now, so many students ask, ma'am, it has lone pair of electrons. So why this is electrophile? This should be a nucleophile. Why this is electrophile? Because carbon has 1, 2, 3, 4. Okay, what is the number of electrons that carbon is having? 1, 2, 3, 4. Okay, 5, 6. It has 6 electrons. That means it is electron deficient here. That is why it is acting as electrophile here, right? Okay. So now that is the key point in this case. The second step will be you have this phenol here, right? Phenol. What is base is going to do? Base is going to abstract the H positive from this side, right? And you will have the formation of you will have the formation of this phenoxide ion here, right? After the resonance, again it is going to have negative charge here. It is going to have negative charge here, the double bond here. Now, similar way that we did for Kolbe's reaction, similar way we are going to do this. Okay, this electrophile is going to attack here, the electrophile is going to attack here, or this arrow should be like this. Okay, this is going to attack here, right? Okay, after this, it will attack on the ortho position, right? And again this H positive will transfer intramolecularly. This H positive is going to transfer here, right? This electron is going to shift here, there will be negative charge here, and after that you are going to replace. Now the next question is, you have 2 Cl2 here, okay? Replace these 2 Cl2 by adding NaOH, right? After this Cl2 will be replaced by OH, right? This is OH, this is OH. If one carbon atom has 2 OH, now that is not stable, so it is going to release water and it is going to form aldehyde in this case. If you see this is COH, this is COH, okay? So it is going to release this one and it is going to form C double bond. Right? How this is going to form this? It is C, this is OH, this is C, this is OH, and this H positive will go from this side, OH negative will go from this side. The electron will be provided to this one. You will have the formation of C double bond, right? And hence you will have the formation of salicylic aldehyde. Okay, everybody? Yes, understood? Understood, everybody? Everybody in the chat box, understood or not? Everybody in the chat box. Everybody in the chat box understood this or not? Everybody in the chat box understood this or not? Shall we move ahead? Next we have phenol with zinc dust. It is going to form benzene, okay? Very simple reaction used in your conversions, right? Next, oxidation, very important reaction. If you have phenol in presence of O2, CrO3, it is going to give para-benzoquinone. Okay, it is going to give para-benzoquinone. Okay, it is going to give para-benzoquinone. Understood this? Yes, perfect. Next is oxidation if you have K2S2O8. In this case, if there is oxidation, you will have catechol and quinol. Okay. In this case, if you have oxidation, you will have catechol or quinol that we have done. That is dihydric phenols. Okay. Dihydric phenols. Yes. Now, here comes 2 charts. I want all of you to answer this and recap everything that we have discussed. Okay. Recap everything that we have discussed till now. Are you all ready for this? Are you all ready to give me an answer? I want your answer in the chat box now. Now be active in the chat box, okay? Now be active in the chat box. Everybody here, I know you are listening very carefully, listening to everything that I am saying, noting it down. Now is the time for you to use the chat box, right? Okay, everybody, are you all ready? Shall we start? Perfect. Now tell me the answer to this. What is the product formed here? What is A? This is A. This is B. This is C. Can you see this? Are you able to see this? This is D. This is E. This is F. This is G. This is H. This is I. This is J. Okay. Now everybody, let us see what are the answer to all these questions. Everybody in the chat box. Everybody in the chat box. Yes, ma'am. Okay. Who all wants to answer now? Okay. Where is the energy? Why are you not even typing in the chat, Bacha? What happened to you all? What happened to you all? Why are you not replying to me? Huh? What happened to you all? Why not replying? Yes, you will definitely get the PDF. You will definitely get the PDF. Now tell me, what is the answer to this? What is the answer to all of this? Everybody. Are you sleepy? Are you having dinner or what happened? So many students are already gone. Okay, ma'am is going to conclude the session now. They don't know half of the session is still left. There are PYQs left. There are so many things that are left here. Okay, so let us solve this. With this, firstly, we have this phenol with aqueous Br2. Very good. With aqueous Br2, you have the formation is 2,4,6 tribromophenol. Okay, with this, if you have phenol that is converted to ortho and para, and you have at ortho and para SOH, then you will use here oleum. Okay, oleum is used here. You will use here oleum, right? After that, with concentrated H2SO4, you have 2,4,6 trinitrophenol, right? With CH, with this is okay. With Br2 and CS2, you will have the formation of ortho and para product, right? And then we have, this is dilute HNO3, you will have the formation of ortho and para product. With Na2Cr2O7 H2SO4, what will the G product here? Everybody, what is this reaction? Everybody. Okay, firstly tell me what is one. This is CHE and this is CHE. What is this? This is nothing but Friedel-Crafts alkylation. Friedel-Crafts alkylation here. Okay, this is Friedel-Crafts alkylation. What is this? That is C product. This is CHCl3 aqueous NaOH. With CHCl3 aqueous NaOH, that is Reimer-Tiemann reaction. That is Reimer-Tiemann reaction. You will have the formation of salicylic aldehyde. Right? Here you have NaOH CO2. This is Kolbe's reaction. This is Kolbe's reaction we are talking about. You will have the formation of salicylic acid. Here you have CCl4 NaOH. That means they are talking about Reimer-Tiemann reaction. But in this case, they are saying it will lead to the formation of salicylic acid. Right? Here it will lead to the formation of salicylic aldehyde. Okay? Right, everyone? Very good. So here, what is the answer to Na2Cr2O7 H2SO4? We are just in this. So due to para-hydroxyquinol. Okay? This will lead to the formation of this product, right? We will have the formation of this product here, right? Okay, everybody. All the questions are answered here, right? Let us see here. I have not answered it here. This is, the answer is this one. Right, everybody? Clear to everyone? Yes? Okay. Now, next is this one. What is the answer? Everybody here, what is the answer to this question? If you want to convert, this will be actually, leave this, wait. From this you will have this, and after that, okay, perfect. See everyone, benzene to cumene. What is this? This is called cumene, okay? This is called cumene. Right? This is cumene process, everyone. This is cumene process. Benzene to cumene, you will have phenol plus acetone. What are the reagents used in this case? What this is cumene process, okay? First you need to have either Friedel-Crafts acylation or anything. You need to have isopropyl carbocation, right? After that adding the air, right? Air, oxygen, and then hydrolysis. You will have the formation of phenol plus acetone. That is cumene process. This is phenol to NO2, okay? Phenol to NO2 is nitration, okay? This is nitration, right? This is benzene to NO2, benzene to nitrobenzene. That is simply nitration, okay? Simply nitration. Everyone, is there any lagging? Is there any lagging here? Is there any lagging here? Okay, this is benzene to nitrobenzene, that is nitration. After that, aniline. Okay, this is reduction with metal, right? Reduction with metal and acid. Okay, reduction with metal and acid. After that, this aniline is getting converted to diazonium salt. That is NaNO2 plus HNO3. Okay, plus HCl, sorry. NaNO2 plus HCl at 0 to 5 degrees Celsius, diazonium salt. And after this, getting it converted into phenol. Just water and then warm it. Okay, add water and warm it. You will have the formation of phenol here. Right? Next you have from benzene to SO3H. Add oleum here. Oleum. After this SO3H to ONA. You will have NaOH fused. NaOH fused, right? And then converting this to this, you will have acidification, that is H2O and H positive, right? Okay, everybody? Namaskaram, namaskaram. Understood this? Right? Okay? So you have this process here. O2 oxidation, H positive, cumene, and this is called, here you will have phenol plus acetone. In this case only. Okay? In this case only you will have the formation of acetone. Not in other processes. Okay? Not in other processes. Right, everybody? Okay. Now let us understand the properties of ether. Understood? The preparation of ether. For preparation of ether, very important, that is Williamson synthesis. Right? Okay, everybody. Shall we start preparation of ether? Clear? Okay, let us start preparation of ether. So ethers are symmetrical or unsymmetrical. Symmetrical means on both sides you have same alkyl groups. Unsymmetrical means there will be different alkyl groups on the different sides, right? Okay, so first thing is preparation of ether, that is dehydration of alcohol. For dehydration of alcohol, always remember this. Okay, if you have where excess of alcohol is heated at 140 degrees Celsius in presence of protic acid, so in this case you will have the formation of ethers here. Okay, in this case you will have the formation of, at 140 degrees Celsius you will have the formation of ethers in this case. Okay, so 2 molecules of alcohol eliminate 1 molecule of water. Okay, what does this mean? So there are two kind of dehydrations. Okay, in case of alcohols, one is from the molecule itself. If you have C, this is OH and this is H. The dehydration can be the OH is eliminated from this and H positive from this side, and you will have the formation of alkene. Right? Okay, that is from one molecule. And if we are talking about at 140 degrees Celsius, in this case you will have the formation of ether. That means OH from this side and H from this side. Right? In this case you will have the formation of ROR. Okay, that is dehydration at 140 degrees Celsius. Right? Okay, perfect, perfect. Next we have dehydration of alcohol is an SN2. Dehydration of 1 degree alcohol to form ether is SN2 mechanism. Okay, for primary it is this is an SN2 mechanism. So the steps is according to this. You have base, this is the base, it will attack on this H positive, it will take the H positive, okay, from the acid, right? It will have the formation of protonated ethanol, and after that this alcohol, the another molecule of alcohol, this is electron rich, this is electron deficient, right? This is electron deficient, this is electron rich. So this lone pair is going to attack on this side, and this oxygen is going to take away the electrons here. Understood this? Firstly, this oxygen is very greedy right now. It has positive charge. It is electron deficient. It wants to pull the electrons. So it is going to pull the electrons from this bond, right? So this will be electron deficient. And for help of this CH2, this another molecule of alcohol will come, right? It will donate the oxygen, it will donate the lone pairs here, right? Again it will have a positive charge here, and then it will lose the H positive. It is going to take the electrons from this, it is going to eliminate H positive, and hence it is going to lead to the formation of ethers here. Okay, it is going to the formation of ethers here. Understood, everybody? Understood? Right? So that was according to SN. This was according to SN2 mechanism. Okay, this was according to SN2 mechanism. Now let us see if in accordance with secondary and tertiary alcohol, they form alkenes by E1 mechanism. Okay, secondary and tertiary alcohol forms alkene by E1 mechanism at 140 degrees Celsius. Right, you have 2 degree. In this case, they are going to form alkene. That is going to be the major product. Right? Okay, Sedgwick rule, according to the Sedgwick rule. For 3 degree alkene, again it is going to form alkene in this case at 140 degrees Celsius. So dehydration of alcohol is in the order tertiary, then secondary, then primary. Primary is going to form ether. Okay, and these two are going to form alkenes. Understood this, everybody? Understood this? Yes, everybody. Now next step, that is Williamson synthesis. Very important reaction. Very, very important reaction. Okay, very simple and very important reaction. That is, you have you have RH plus RONA. It is going to form ROR, right? Okay, understood this? Plus NaX, plus NaX. This is a simple reaction here. Now, why this is so important? Even the last year a question is asked from this one. Because there the tricky part is, which bond will be broken here? The tricky part is that. What kind of alkyl halide you want? What kind of this ONA part you formed? Okay, what kind of alkyl halide? What kind of RONA? Right? Okay, that is the tricky part here. Right? Right? Okay, so let us see. Heating of alkyl halide with sodium potassium alkoxide. This is very good method for preparation of simple and mixed ethers. For this, and that was also, this was for simple ethers, okay, right? So in this case, you have RONA, RX, and this is going to give ROR. Now let us see the mechanism here, right? Nucleophile substitution reaction, this is according to SN2 mechanism. First, you will have the formation of C2H5, you will have the formation, this alkoxide is going to release, Na positive, okay? So it will have the formation of this carbonyl, right? So now, what is going to occur next? Now this is the halide here. So in the slow step, okay, this halide, this is the O negative part, this is the partially negative part, this is the partially positive part of halide. This partially positive part is going to attack here. It will lead to the formation of this transition state, where this O negative is going to attach to this alkyl group of alkyl halide, and this alkyl halide is going to break the bond of alkyl and halide. Okay, this is a transition state. This is the transition state. This is the transition state. So after this is the slowest step, right? That is why it is SN2 mechanism. After that, it is going to release I negative and will lead to the formation of ROR, that is ether. Now, what kind of alkoxide and what kind of alkyl halide you want, right? So alkyl halide, this is a very important step, because they directly ask what is the can this be formed or this cannot be formed. Simple question. Okay, alkyl halide should be primary, alkoxide can be secondary or tertiary. Always remember this. Alkyl halide should be 1 degree, right? Alkyl halide should be primary. What is the reason behind that? From the mechanism, as you can see, firstly, it leads to the formation of carbocation, right? It will lead to the formation of carbocation, right? Okay, alkoxide ion is formed here, right? Now, this alkoxide is going to form a transition state. So, we do not want steric hindrance here. If this is 3 degree, this is 2 degree, there is going to be steric hindrance. So, it will find this alkoxide ion is going to find it very difficult to attack on that, right? And that is why this should be 1 degree. Okay, this should be primary. Okay, that is the first thing. Okay, this method is not applicable to tert alkyl halides. This is not applicable because of steric hindrance. The alkoxide ions are powerful nucleophiles and bases that would bring dehydrohalogenation of the tert alkyl halides to form alkenes preferentially. Okay, so in tert alkyl halides, alkenes are formed instead. Okay, the alkoxide ion are powerful nucleophiles and bases that would bring dehydrohalogenation of tert alkyl halides to form the alkenes present there. Right? Okay, everybody? Yes. So now Williamson synthesis limitation. What is the limitation of this? Now this is the limitation. If you have this is 3 degree, this reaction is going to form alkene in this case. Okay, this reaction is going to form alkene in this case. Right? There will be no formation of ether here. That is the limitation here. Right? Due to steric hindrance, secondary alkyl halides prefer to undergo elimination rather than substitution. Even the secondary alkyl halides produce here, major part is they form ether also, but the major part is alkene here, not ether. right? So that is why 1 degree halide is preferred in this case. Aromatic halide cannot be used in Williamson synthesis reaction. What is the reason? If you're using this one, if you're using aromatic halide, okay, it needs to break this bond. It needs to break this bond. But this bond is not going to broken here. We can't break this bond. There is partial double bond character in this case, right? The electrophilic difference is very good. So what will happen here? It will not break this bond. So aromatic halide cannot be used in this case. If strong electron, very important thing, if strong electron withdrawing group at ortho and para position are present, then reaction take place. It means if you have at ortho and para position you have nitro group. At this you have nitro group. So it is going to pull the electron density, right? It is going to withdraw the electrons and thus make it, because everybody, if you have, it is going to, this is actually having partial double bond, okay? There will be negative here, there will be negative here, there will be negative here in the resonating structures, right? So if there is ortho and at ortho and para position you have electron withdrawing group, it is going to withdraw the electrons, okay? When it is going to withdraw the electrons, then it is going to stabilize it, right? It is going to make it more vulnerable to the attack, right? Because it is going to take away the electron, the negative part it is going to take away, right? That is why this halide, this bond can be broken down in that case, okay? If you have at ortho, and same in that we did in case of Dow's process, okay? Similar thing, right? Okay, similar thing we are talking about. Now, phenolic ethers can also be prepared in similar way by treating sodium peroxide. Now, they are saying if you want to make phenolic ethers, okay, if you want to make this one, okay, this question is asked in your PYQ, okay, this is your PYQ 2023 question, I guess, 23 or 22 question. This is asked, okay, very simple question. So now, this is anisole, right? This is alkyl aryl ethers. So here they will ask you what you want to take. Do you want to take these two things as reactants? Can you take this as reactant? Everybody in the chat box, can you take this as reactant? We cannot use these as reactants, right? Because breaking this bond is difficult. But we can use this reactant. We can use these reactants. You have ONA plus you have CH3X. We can use this reaction. Okay, this is feasible. This is not feasible. Okay, this product, this aryl halide will be formed. This aryl ether, this alkyl aryl ether will be formed with the help of not aryl halide, but alkyl halide. Okay, this is the important thing here. Okay, yes. Next is reaction with HX. Now you have the preparation of ester, preparation of ether. With reaction with HX, if you have this HX here, this bond will be, these are the reactions of ether, okay. Now this is also very important, asked in your PYQ, very important reaction. That is reaction with HX. Why this is important? What is the reason this is important? Because we don't know if we need to break this bond or this break. We need to break this bond. So which bond to break? This one or this one? That is the key point here. Whether we should break this one or whether we should break this one. Okay, that is according to the question. Right? That is according to the question. For example, you have this thing. This is actually asked in your previous year exams. That is OCH3, right? If you have this thing and you are treating this with HI. So what will be the products here? We cannot break this one because this has double bond character. We cannot break this this oxygen that is linked to the aromatic ring because of resonance. It has double bond. So here you will break this bond instead. This bond will be broken and you will have the formation of OH here and this is CH3I here. Okay. This is the question that is asked. Okay guys. Okay guys, everybody. Ma'am, for any reaction is question on mechanism. Yes, these all questions are from your mechanisms only. And if you don't know the mechanism, how you will be able to answer the questions? Because you need to know what is actually happening in the mechanism. Only then you will be able to understand what should be the product. Right? What is the slowest step from how it is proceeding? And the order of reactivity is HI, then HBr, then HCl. Now, reaction in alkyl aryl ethers are cleaved at alkyl oxygen bond due to more stable aryl oxygen bond. The reaction yield phenol and this. Okay, this is the reaction that I was talking about. Now, this is the mechanism, that is SN2 mechanism. In this case, you have HI, right? It will form a transition state in this case. It will form a transition state in this case, right? Okay, the step 2 will be, it will form a transition state. The I will be attacked here. The I will attack here. It will lead to the transition state here. And hence, after that, it will lead to the formation of alkyl halide and 1 alcohol. Right? Okay. Next is cleavage of mixed ethers with two different alkyl groups depends on the nature of alkyl groups. So now how will you differentiate if you have R-OR? Which bond will be cleaved here? For aromatic and aryl, if you have aryl and alkyl, you know the bond that should be broken, that should be alkyl bond, not aryl bond. If you both have alkyl, then what should happen in this case? Okay, so if both the groups are alkyl nature, so this bond should be broken or this one? What is the answer to that? This is according to the primary, secondary and 3 degree, right? So when primary or secondary alkyl groups are present, it is the lower alkyl group that forms alkyl halide, or you can say halide here. Always remember this. When primary or secondary alkyl group are present, the lower alkyl group that forms alkyl halide. Okay, everybody. Lower alkyl group is going to form alkyl halide. For example, wait. Okay, this is the example here, right? So how you are going to answer this question? Okay, how you are going to answer this question? Here you have 1 degree and here you have 3 degree. Here you have 3 degree, right? Okay. So in this case, tertiary is present here. Wait. This is for tertiary, right? Okay. Wait. I'll do one for this one. Okay. I'll do one question for this one. Okay. Let us take this example only. You have CH3, CH2, and this is H, right? Okay. So in this case, what thing will be formed in this case? This is not, this is alcohol. Okay. I'll just write it down as this one, okay? I'll write another example, that is CH3, CH2, that is OCH3. Okay. So now, both are 1 degree. Okay? Both are 1 degree, everybody. This is 1 degree and this is also 1 degree. If we have both has 1 degree, okay, if both are 1 degree, okay, if when primary or secondary alkyl group are present, the lower will form alkyl halide, okay. So in this case, which is the lower? That is CH3, okay. So it is going to form CH3I plus CH3 CH2OH. Understood this? Bacha, see, if you have this question is asked, okay, that is why I am asking you to do this question. If you have, for example, you have CH3 here, right? Okay, this is C, this is CH3 here, this is CH3 here, this is O, this is CH3, CH2, CH3, okay? Now, this is 2 degree and this is 1 degree, right? If you have primary or secondary, in that case, lower is going to form the halide. So in this case, this is going to form the halide. This is CH3, CH2, X, and it is going to form CH3OH. Okay. Lower one is going to form the halide. Okay. Similarly, we can also take another example. That is, if you have CH3, CH2, CH2, OCH2, CH3, right? In this case, which is going to form halide and which is going to form alcohol? Everybody. Yes, I am repeating that. Now both are primary. This is primary and this is also primary alkyl group. Both are primary. If they are primary or secondary, if the alkyl group is primary or secondary, the simple case is lower alkyl is going to form halide. So the lower alkyl is this one. So it is going to form halide here. This is CH3, CH2X plus you have CH3, CH2, CH2OH. Understood this? It is going to form, okay? No fluorine here. Yes, fluorine is not here. Okay? Fluorine is very explosive. So, this is in case of when you have both the alkyl group as primary or secondary. But if the alkyl groups are tertiary, if one of the alkyl group, very important, very important, that is why this reaction is very important. We don't know how to break the bond. There are specific rules for that, okay? When one of the alkyl group is tertiary, if one alkyl group is tertiary, the halide formed is tertiary halide. This follows SN1 mechanism. Right? For example, you have this one, okay? This is tertiary. This is 1 degree and this is 3 degree. Right? In this case, it is going to break, the tertiary one is going to form the halide and the other one is going to form alcohol. If any of them is tertiary, the tertiary one is going to form halide. If both are primary or secondary, lower one is going to form halide. Okay? Okay, everybody, I'll write it down for you to summarize it. Very important. I'll summarize it for you. So if you have primary, if alkyl groups are 1 degree or 2 degree, then the lower one is going to form halide. Lower one is going to form halide. If next you have, if the alkyl group is tertiary, if any of this is tertiary, 3 degree is going to form the halide in this case. Understood this or not? They will ask you question regarding this, okay? In ethers, two things are important. First is Williamson synthesis. Next is second is this reaction. Okay? Okay, everybody? Okay, everybody? Yes? No, you don't need to get into Markovnikov rule and all that. Just simply write it down. Alkyl group 1 degree, 2 degree, simply lower will form halide. Okay? If you have alkyl group that is 3 degree, it will form halide here. Okay? 3 degree is going to form halide here. Also as direct mechanism. Ma'am, is question also asked on direct mechanism. In NEET, don't ask a direct mechanism question. But if these conclusions are from your mechanisms only, okay? This conclusion part is from your mechanism. If you can see from the mechanism, because we know this is a SN2 mechanism. In SN2 mechanism, this is according to the steric hindrance, right? And that is why we say, in this case, you will have a transition state here, right? And that is why we say the alkyl halide is formed by lower one because of the steric hindrance here. Right, because of the steric hindrance that is involved in this case. Okay, because of the steric hindrance that is involved here. Right, okay, because this halide is going to attack on that thing which is having less number of, where there is less steric hindrance, which is lower, okay, which is having less number of carbon atoms, because that is having less steric hindrance. Right, now you can see this from the mechanism only. This is halide, this is attacking on the this group, right? Okay, so it is attacking on that part where there is less steric hindrance. That is why we say for 1 degree and 2 degree, where it follows SN2 mechanism, it is going to form lower halide. Okay, lower halides will be formed here. Okay, I'll also write one thing here. For tertiary, the mechanism is SN1. That means it is going to form carbocation in this case, right? For carbocation formation, after the carbocation formation, there is no steric hindrance factor here, right? So it is going to form, if there is 3 degree, okay, this is more stable. As you know, the stability of carbocation is this. So that is why halide prefers 3 degree. That is why we say if any of it is 3 degree, it is going to prefer, halide is going to form a tertiary halide, right? This is totally because of the steric hindrance factor, right? If you don't know the mechanism, how will we know this, right? We know that this follows, Sn, this follows, let me write it here. This follows SN2 mechanism and this follows SN1 mechanism. As we know, in this case, steric hindrance is the factor. That is why lower halides are formed because of steric hindrance. In this case, carbocation is the factor. That is why 3 degree halide is formed. Understood this? This is according to the mechanism only. But if you know these conclusions and you know this is SN2 and this is SN1 mechanism, in that case, you don't need to remember all the steps of mechanism. If you know this concluding part of it, okay? Okay, everybody? Okay, everybody? Yes. Okay, perfect. Now, next we have this one, okay? We have already done this. It is not the bond here. This one is not going to break here. It will not break this bond here. That is between this aromatic carbon and this oxygen because of the partial double bond character here. Okay? So, it will break this bond and you will have the formation of phenol and alkyl halide, right? Okay, always. Next is carbon of phenyl group is sp2 hybridized and there is partial, all these things that I have just said, all these things are written here. Phenols does not react further to give halides because sp2 hybridized carbon of phenol cannot undergo nucleophilic substitution reaction. Okay, next is if that is ortho. Okay, now let us see the other reactions of simple reactions of alkoxy group. Okay, very simple reaction, just like phenols. Just like phenols, we have this reaction. Okay, very simple reactions. So for halogenation, if you have halogenation, you will have ortho and para product where para will be major. For halogenation, you will have ortho and para product, just same in the case of phenol that we did. Okay, in case of nitration, you will have ortho and para product, right? And para product here, the major product will be, okay, in this case, if they ask you what will the major product, there is no hydrogen bonding here. No hydrogen bonding here. So in this case, major product will be the para product. After this, we have generation of nucleophile, electrophile. You have done this so many times. So many times. From the hydrocarbons, aromatic hydrocarbons, we are doing these things. Right? Okay. So how NO2 positive is generated. This is just repetition of those things. Okay. These things are repeated. Right? This is also, we have done this. Right? Friedel-Crafts alkylation. So now, one thing is asked from this. Okay, from Friedel-Crafts alkylation, you will have the formation of carbocation, right? You will have the formation of carbocation that will be attached to ortho and para position. Okay, so you will have the formation of this one. Okay, this is Friedel-Crafts acylation. Again, you will have the formation of ortho and para product where para will be the major product. Right? Okay, everybody? Yes? It's looking like a wow. Yes. So now this is your homework question. After this we are going to do PYQs. After this we are going to solve the PYQs. Okay. This is your homework question. Let me see. This benzene is getting converted to phenol. This phenol is then converted. Wait. This is not the correct one. Phenol to cumene. Okay. This is not correct. You just need to answer, everybody take a screenshot of this and you need to answer what is A, B, this is C, okay, this is C and this is D. Okay, how to convert benzene to phenol, how to convert phenol to benzene, then we have how to convert benzene to cumene, then cumene to phenol. Okay, answer this A, B, C and D. Take the screenshot of this and answer it in the comment section. Okay, everybody? Before aldehyde and ketones, I want all of you to answer this question. Everybody take the screenshot. There are 20 students right now watching. I want all the 20 students to answer this. Okay, I'll see if all the 20 students are answering this, okay? Even all the students who have seen the recorded version of it, you need to answer this. What is A, B, C and D, okay? Okay, perfect everyone. Everyone will do the homework. Yes, everyone. Yes, yes, bacha. Manipur and NEET exam at Guwahati. I'm so confused to select exam center. Okay, okay. Don't worry. We'll talk on this. You can comment it on the Telegram channel. Okay, Telegram channel. Comment it on my link. Okay, comment it on my link and we will definitely solve your query. Okay, perfect. Yes. Rajay is saying, ma'am, please. Rajay, have you seen my hydrocarbons chapter? Have you seen that? Because in that chapter I have completed that in detail. Aromatic hydrocarbons, we have completed that in detail. Friedel-Crafts, alkylation, acylation, everything. That is just a repeated version. Okay, that is just a repeated version of that. Because OCH3 is an ortho-para directing group. Okay, this is ortho-para directing group. It has this group, it has lone pair, it is going to donate the electron. And that is where there is substitution in ortho and para position. Okay, everybody? Yes, perfect. Now, yes. So, as I told you, practice is also very important. I am making these flowcharts for you, and so our team is making the important mock test according to the new syllabus, according to the latest syllabus. Okay, according to the JEE means examination that has happened. Okay, this happened just 15 to 20 days back. According to that, our team has made specially mock tests, predicted mock tests. Okay, predicted mock tests for you guys that are free of cost. That is Vidyakul. Okay, Vidyakul, you will get 5 mock tests in this case. You will get 5 mock tests. One will be complete 11th. One will be complete 12th. Okay, for first case you will have complete 11th. Second, you will have complete 12th, and 3 mock tests will be full-fledged chapters, all the syllabus. It will have all the 11th and 12th class topics. Okay, newly added topics also. Everything will be included in those mock tests. Okay, so link is given to you in the description box. You just need to click it down and so go to that and download your mock test. Right? Okay, everybody. Next is IV SAT 2024. So this is basically a scholarship program for you to get enrolled into the courses, right? To get enrolled into the paid courses at off. Okay, you will get scholarship from Vedantu. In this case, okay, 100% scholarship. And in this case, firstly you need to register it down. The registration link is given to you in the description. Register it down, then you have to do the test. Okay, you will take your test. Okay, so get admission to our courses up to 70%. But you have 70% scholarship. Centers are now live in your city. Okay, and in this case, that is NEET is also available, right? NEET or JEE also available, right? Okay, so what are the benefits? You can take tests anywhere, anytime, right? Earn up to 2x scholarship by taking AV SAT at offline center. 2x scholarship that is provided to you. 2 times more scholarship will be given to you. Right? Okay, exclusive free one-on-one counseling session with our mentor experts. Right? All the things that are, ma'am, where should we fill the form? What is the registration form? What are the colleges that we should get into? If you have some confusion after your result, everything will be provided to you totally free of cost. As you know, counseling is needed and mentorship is needed. That will be provided to you exclusively, totally free of cost. Right? Okay. So, just book the registration link. And here are the centers that are actually available. Nearby, you can see your city, nearby you, what are the offline centers that are available to you. Right? If you want to give at your home, you can give that. Okay. But if you give at an offline center, right, nearby you, then you will get 2x amount of the scholarship. Understood this? Yes? Okay, everybody? Yes. Perfect. Understood? So now let us start PYQs. Okay, let us start the PYQs. Before that, I also want to show you. So okay, I'll show you that some other day. Okay. NEET 2020. NEET 2020 question reaction between everybody in the chat section. Everybody. Everybody, I want all of you to be active right now. I want all of you to be active. We have completed this chapter. Now we are going to do the PYQs, the practice session that you all were craving for, right? Firstly, we did all the theory part of alcohol, phenols and ether, all the theory part, all the reactions. Now we are going to do don't worry, soon, bacha, soon, okay? So reaction between acetone and methyl magnesium chloride followed by hydrolysis. What is this calling? Okay, what they are saying, you have acetone, this is CH3, C double bond O, CH3, right? This reaction with CH3 MgCl, right? This is positive. So this is negative, this is positive, this is partially positive, this is negative. It is going to give CH3, C, CH3, this is OH, this is CH3, okay? It is going to give us tertiary butyl alcohol, okay? It is going to give us tertiary butyl alcohol, okay everybody? What is the correct answer? Tertiary butyl alcohol, right? Not isobutyl, this is tertiary butyl alcohol, okay? This is tertiary butyl alcohol. Isobutyl alcohol is this one. Isobutyl alcohol is when this methyl, you have this CH3, you have this CH3, and this is CH2, and this is OH. This is isobutyl alcohol, right? This is isobutyl. This is isobutyl alcohol. Okay, that is tertiary butyl alcohol. Okay, everybody? Yes, the answer is C, not D. Okay, do not copy paste. Answer it yourself. Do not copy paste the answers. Okay, he has written D, the answer must be D. I'll write it at D, okay? Do not do that. So everybody in the chat box, why your energy is so low, guys? Yeah, I understand you have been like studying for a while, but please do not do this. These questions are specially for you and you are behaving like this. What happened to you, yaar? What happened to you? So this is NEET 2019 question, right? As I told you, cumene process, right? This is cumene with O2. It will have the formation of A. Now, what is this A? Everybody in the chat box, what is this A? I want all of you to answer this. I am not going to answer this. I want all of you to see the options here and see what is A here. After that, it's just going to hydrolyze and it will form phenol and acetone, right? What is A here? A, B, C, D. A for apple, right? A for Ames, A for Ames. B for what? B for Baswasar. C for cute Gopika ma'am, okay? C for capto, okay? D for Diksha ma'am, okay? So A for will say amazing Gopika ma'am, okay? A for amazing Gopika ma'am, this is Baswasar, this is capto Shreyas sir, and this is D for Diksha ma'am, okay? So what is the answer here? What is the answer here? The answer here is this one, okay? We'll have the O bond between C and H, right? So the answer here is C for cute, C for capto, right? C for capto is the correct answer here. And that is cumene hydroperoxide is the correct answer here. Then you have NEET 2019 question. When vapors of a secondary alcohol are passed over heated copper, when vapors of secondary alcohol are passed over heated copper at 573 Kelvin, that means at 300 degrees Celsius, you will have the formation of which product? For 1 degree, what is formed? For 2 degree, what is formed? For 3 degree, what is formed? Everybody, for 1 degree, you will have the formation of, for 1 degree, you will have the formation of aldehyde. 2 degree, you will have the formation of ketone. 3 degree, you will have the formation of alkene. And here you have secondary, that is a formation of C, that is ketone, okay? Capto is winning here, okay? Capto is winning here. So, NEET 2018 question. You have this phenol and CHCl3NaOH. What is the name of this reaction, everybody? What is the name of this reaction? Everybody, now they have asked, the electrophile involved is. What is the electrophile involved? What is the electrophile involved? We have done all these things today itself. If you have listened to my lecture carefully, you will be able to answer this. Everybody, yes, what is the answer here? What is the answer here? What is the electrophile that is formed. What is the reaction here? The reaction is Reimer-Tiemann reaction, right? The reaction is Reimer-Tiemann reaction. Acetaldehyde is formed here, salicylic aldehyde is formed here, right? Okay, so this is Reimer-Tiemann reaction. In that case, you have dichlorocarbene, okay? You have the formation of dichlorocarbene, that is D is the correct answer, right? Okay, next you have the formation, you have NEET 2018 question. Compound A, C8H10O is found to react with NaOI. Now they are saying compound A, okay, you have compound A that is C8, everybody, C8H10O is found to react with NaOI produced by reacting Y with MaOH, okay, and yields a yellow precipitate with characteristic smell. A and Y are respectively. Everybody in the chat box, what is the answer? मैम नेम भूल गए बट रिएक्शन स्ट्रक्चर याद है, रिएक्शन याद है, ठीक है. डाइक्लोरोकार्बीन, ठीक है, दैट इज DCC is formed here. Okay, a compound this, okay, is found to react with NaOI, okay, produced by reacting with Y with NaOH, yields a yellow precipitate. Very simple reaction, everybody. Yes, what is that form? What is that formed here? Everybody. Now, see, you will have this compound, okay? Now, this compound, the compound A, that is reacted. You have NaOH, that is I2. And here you will have the formation of NaOI. Now, this NaOI is reacted with this, right? This alcohol. So, after this reaction, what it will do? This is alcohol, right? This is NaOI. It will lead to this Na positive, this, wait, this is double bond O. Okay, there will be the formation of this is basically iodoform test, okay, this is basically iodoform test. I think there is option, okay. So what they asked in the question, wait, they asked in the question, compound A, this is found to react with NaOI. That here you can easily get the hint of iodoform reaction, right? And this yellow precipitate gives you the hint for iodoform reaction produced by Y. They are asking about A and Y, right? R respectively. Okay. I thought they are asking about yellow precipitate. That's why I was looking for CHI3. Okay. So now what is this Y? This I2 is going to react with NaOH, right? It is going to form this is going to form NaOH, right? NaOI. And this is basically haloform reaction, or we can say iodoform reaction. So what it is going to form? This is going to form this one, okay? Understood this? And what is this A compound? The A compound is this, right? Okay, everybody. This is going to give positive iodoform test. You have to select those alcohols that are going to give positive iodoform test. Okay, you have to select those alcohol. Basically, they are asking which is going to give you positive iodoform test here. Okay, which is going to give you positive iodoform test, right? This is going to give you positive iodoform test, right? This is secondary alcohol is going to give you positive iodoform test, right? Okay, understood this? 2-degree alcohol is going to give you positive iodoform test. Next you have 2018 question, the major product PQR in the following reaction. Again Cumene process is asked here. This will form Cumene in this case. Where is Cumene? Everybody, where is Cumene? Here you can see the Cumene. So you know the answer here. Okay, everybody, you know the answer here. This is Cumene, right? Again O2, then hydrolysis, you will have Q and R. That is phenol and acetone. Okay, that is phenol and acetone. Okay, everybody, this is Cumene, this is also Cumene. But here you have phenol and some other compound, alcohol. We need to have phenol and acetone, right? Okay. Next is 2017 question. Which of the following is most stable acidic? Most acidic compound. Which is most acidic out of this? Which compound is most acidic, everybody? Out of this, which is most acidic? You have this. Now you know this is electron withdrawing. This has electron withdrawing character. It is going to pull the electron. Picric acid, even more strong acid than carboxylic acid. Okay, even even more strong acid than carboxylic acid. So C is going to be the right answer, that is picric acid. Okay. Next is 2015 question. Reaction of phenol with chloroform in presence of dilute NaOH. Now you know the answer. Find introduces which of the following functional groups. They are talking about which? They are talking about which reaction? Very good. 246 trinitrophenol. Very good. Which is going to be the answer here? You have chloroform CHCl3 along with dilute NaOH finally reduces which? What is the naming reaction? What is the name of this reaction? We have just done this reaction. What is the name of this reaction? Reimer-Tiemann reaction. Okay, very good. Reimer-Tiemann reaction. It is going to no. It is going to introduce CHO group. Okay. For Reimer-Tiemann reaction with chloroform, it is going to introduce CHO, right? If there is CCl4, it is going to introduce COH group, okay? For CCl4 Reimer-Tiemann reaction, it is going to introduce COOH, okay? Why D, bacha? Why D? CHO is the right answer. Salicylic aldehyde is going to be the right answer here, right? Okay. So next is NEET 2015 question. Which of the following reactions can be used for preparation of alkyl halides? Okay. For alkyl halides, this is OH, this is HCl. This is OH, this H positive is going to pull the okay. This is HCl, this is anhydrous ZnCl2. Right. Okay. So the following can be used for preparation of alkyl halides. Okay. For alkyl halides they are talking about, right? This is HCl, this is anhydrous, this is basically Lucas test they are saying, which is going to form the alkyl halides. Okay everybody, this is Lucas test, everybody. For tertiary, Lucas test, yes. For primary, Lucas test is actually takes place after such a long time, right? So what will be the correct answer everybody? What will be the correct answer? Okay, this is Lucas test, okay, this is Lucas test. This is simple HCl, right? Simple HCl. H positive is going to take the D for Diksha, ma'am. Acha. 1, 3 and 4 you are saying. Okay, 1, 3, okay. 1, 3 and 4. Okay. Okay. So C. Wait. Okay. So 1 degree, 2 degree react with HCl in presence of ZnCl2. Lucas test. Right? Okay. This is done. This is done. This is tertiary and this is primary. So this is not, there is no Lucas test here. This is no Lucas test. This is not Lucas test. So while in case of 3 degrees Zn2Cl2 is not required. Okay. In case of tertiary ZnCl2 is not required. So we are going to say, so in this case simply it is going to release the, wait, this is tertiary. This is primary, so this is not going to give. So answer will be 1, 3 and 4. Yes. So answer is going to be 1, 3 and 4. Next we have anisole on cleavage with HI. This is NEET 2020 question. Anisole, what is anisole? OCH3 on phenol. Everybody? Sorry, what? Okay, everybody, anisole on cleavage with HI gives. Anisole on cleavage with HI, it is going to give what kind of reaction? With HI, it is going to give, it is not going to break the bond of carbon and oxygen, right? So it is going to give us what? Everybody, what it is going to give us? Anisole is this, right? Anisole is going to give us. The answer is yes, A for Ayodhya, okay. So it is going to give answer A, right? Okay. Next is, see this reaction. So it is not going to break this bond. This bond will be broken down and you will have the formation of phenol and CH3I, right? Next is NEET 2019 question. The compound that is most difficult to protonate. The compound that is most difficult to protonate. What is that compound? The compound that is most difficult to protonate. Why I have written the right answer here? Okay. I think my energy is getting low. The compound that is most difficult to protonate is this one, right? Why so? Because here it will be stabilized by resonance, right? It will most difficult to protonate, right? Most difficult to protonate. We're going to give the proton here. For proton, there should be electron deficiency, right? So here it is stabilized by resonance. It is stabilized by resonance. So because of that, it does not need any proton further. This electrons, this lone pair is already stabilized. Okay, this is already stabilized by resonance. So answer is this. Okay, my bond is broken with her. Okay, I know Valentine Day is coming, so you are remembering something, huh? So NEET 2019, the major products C and D formed in the following reaction respectively are. Very important question. Very important question. Okay, C and D respectively are. Which should form halide? Everybody, this is 1 degree. This is 3 degree. So if you have 3 degree, that follows SN1 mechanism. Always 3 degrees form. 3 degree halide is formed here. Okay, 3 degree halide will be formed here. This is wrong. This is wrong, right? And in this case, other is this CH3, CH2, CH2. And that is alcohol is formed in this case. So you will have the formation of B is the correct answer. Why we have written A? Wait. Oh, okay. So here we have excess of HI. Okay. Here you have excess of HI. In case of excess of HI, both the things that are formed are halides. Okay. Both the things that are formed are halides. If you have ether, okay, and if you have ether, this phenol, this alcohol further gets converted into halide, okay, because as you all know, for example, this alcohol is formed, okay. If you have excess of this is also again an important question. Then you have this CH3, this is CH2, this is CH2 and this is OH, right? Okay, so in this case, again, because HI is in excess, okay, with alcohol you have HI. What will be the answer? There will be substitution and you will have the formation of CH2I in this case. Understood this? So for excess of HI, you will have both the halides. Alcohol will be further converted into halide. If there is no excess of HI, if there is just HI, the answer will be B. Okay, the answer will be B in that case. Understood this? Yes. Perfect. If there is no excess of HI. Next is 2017. The heating of phenyl methyl ether with HI produces phenyl methyl ether. Phenyl methyl ether. Same question 2017 anisole they are talking about, right? Phenyl methyl ether with HI, this produces what? This produces everybody. This produces phenol benzene ethyl chloride iodoform. What does this produce? This produces phenol, right? This bond will be broken down. Very good, right? Okay, next is 2016 question. The reaction this NaH, right, with NaH, then after that with methyl iodide, it will lead to this one, right? Can be classified as. So what is this classified as? What is happening in this reaction? Dehydration reaction, William alcohol synthesis reaction, William ether synthesis reaction, alcohol formation reaction. So you have this alcohol that reacts with NaH, right? This is positive, this is negative, this is positive, this is negative. So there will be replacement of H with Na, right? You will have this product. After that, this is your alkoxide and you have this halide. Halide, that means Rx and RONA. Then formation of ROR. This is Williamson synthesis reaction. That is C is the correct answer. Right? Okay. Then you have 2015. That is, this is tertiary. Okay. Fine. Okay. Okay. Now you have this alkoxide and this is the halide. We always know halide should not be tertiary, right? Halide should be primary. The other alkoxide can be tertiary, right? So this reaction will take place and we'll have the formation of ether here, right? So this is a retard reaction, Getterman, Williamson says Williamson continues with esterification process. Everybody, what is this reaction? Very simple. This is Williamson synthesis reaction, okay? But they can ask you, they can alter this and they can ask you, okay, if you have CCH3 thrice X plus CH3 CH2 ONA. Will this reaction take place or not? Everybody in the chat box. Will this reaction take place? Can halide be tertiary? Will this reaction take place? Again, I am correct. Very good. Will this reaction take place? Can halide be tertiary? Can we say halide can be tertiary? Is this possible? Everybody in the chat box. Is this possible for a halide to be tertiary in case of Williamson? भी हो सकता है ना ma'am? No बच्चा, this itself is esterification. This is not an etherification process, okay? This naming reaction of formation of halide or formation of ether from halide and alkoxide is called Williamson synthesis, okay? This is a Williamson synthesis. There is no continuous etherification process, okay? This is not the right Williamson continuous etherification process. No, this is simple Williamson synthesis reaction. Okay, so this cannot take place. So they can modify this question according to this. This because this is a very simple question, but they can modify this question like this. Okay, they can ask you, will this reaction take place or not? Right? Next you have 2023 question. Consider the following reaction. Identify the product here. Okay, you see so many questions are from this. Okay. Consider the following reaction and identify the product here. You have HBr, right? This is 2-degree alcohol here. What will be the product here? Everybody, what will be the product in this case? Simple HBr, you have OH, right? You have alcohol. What will be the correct answer? Everybody, what will be the What will be the correct answer? Will there be any dehydration? And will there be replacement simply? Will there be any rearrangement here? We have rearranged the product here. Will there be rearrangement like this? Will there be formation of carbocation in this case? Everybody. Will there be formation of carbocation? Everybody. Yes. Very good. Okay. There will be rearrangement of carbocation. Okay, for this we have the rearrangement of carbocation methyl shift and hence the product, the answer will be D. Okay, here first you will have the carbocation this. Okay, this will be the carbocation formed here and there will be methyl shift and after that this is 2-degree carbocation. After the hydride shift, not methyl shift, there will be hydride shift. Okay, no methyl shift is going to take place here. Hydride shift. Okay, no bacha, no methyl shift. Okay. There will be hydride shift, okay? Hydride shift. We are not shifting any methyl here, okay? We are shifting this hydride here. This hydride is shifted to this, okay? So you'll have the formation of 3-degree and hence after that you will have your product, right? Next is 2014 question. Which of the following will not be soluble in hydrogen carbonate? Hydrogen carbonate basically reacts with acids. So which is a good acid? Which is not a good acid, that will not be soluble, right? Which is not a good acid, right? Okay, everybody. Bromination is selective to 3-degree attach. No. Bromination and chlorination selectivity is in case of, that we do in case of Friedel-Crafts reactions. If you're doing this or this, in that case we see, okay, this is not that concept that we have done in hydrocarbons. That was in presence of UV light. If you do this Friedel-Crafts chlorination, right, in that case we used to see the selectivity of chlorination, but in this case simply rearrangement reaction. Okay, understood this? Yes. So this is orthonitrophenol because this is not acidic. This is acidic, this is acidic, this is acidic, this is not acidic, so answer will be C. Okay, answer will be C. Next is 2012 question. Which of the following sequence of reaction, in the following sequence of reaction, the end product is, what is the end product? You have CH3Br, it reacts with KCN, okay, it will form A, and after the hydrolysis it will form B, and after the reduction it will form C. What will be the end product here? What will be the end product here? So everybody, these kind of questions are also asked in the exams. Okay? Yes, the end product is ethyl alcohol. One is saying alkyl alcohol, other is saying acetaldehyde. Okay? Okay. Let us see. One is saying B for best, Diksha ma'am. Okay? That is methane. Okay? A, no one is saying D for Diksha ma'am. Okay, perfect. So let us see this. CH3Br with KCN. Simply replace Br with Cn. After the hydrolysis, you have this C triple bond N, right? After the hydrolysis, you have this C triple bond N, right? This C triple bond N. This is partially negative. This is partially positive. The two pi bonds are going to break here. Okay. So this will be C. This is basically this will get converted into COH after hydrolysis. Okay, how does it get converted into hydrolysis? Because there will be COH, OH, and this will be hydrolyzed. This will the water will be eliminated and it will lead to the formation of COH group here, right? And hence you will have COH here. And after the reduction with LiAlH4, because LiAlH4 reduces COH to alcohols, we have done that. If there is, tell me one thing, if there is NaBH4, what is the answer? There will be no reduction of COH group, okay? No reduction of COH group. In this case, in case of LiAlH4, there will be reduction, okay everybody, there will be reduction. So you'll have the formation of alcohol here. So the answer was D for Diksha ma'am. Ethyl alcohol was the right answer, okay? Not to alkane, to alcohol we studied. LiAlH4 reduces carboxylic acid to alcohols. Okay, not to alkanes. Not to alkanes, okay? It reduces, yes, to alcohols. Okay? So it reduces only by LiAlH4. COH or ester is reduced by LiAlH4. Understood this? Yes, yes everybody. Understood this? Okay? Next question, 2010. Given our cyclohexanol, acetic acid 2,4-trinitrophenol, and phenol in these, the order of decreasing acidic character. The order of decreasing acidic character, everybody in the chat box. You have cyclohexanol, right? Then you have acetic acid. You have 2,4,6-trinitrophenol and you have phenol. Which is more acidic? Right? Everybody in the chat box, what is the decreasing order? Everybody? See, second you are saying acetic acid, okay. Then you are saying third, that is triphenol, okay. Then you are saying first, that is cyclohexanol. Then you have placed phenol at the end, okay. Okay. See this very carefully. See this very carefully. C is not the correct answer. Okay. A for awesome, Diksha ma'am. So third, very good. Trinitrophenol, very good. Then second, that is acetic acid. Then fourth, that is phenol. Then one, that is cyclohexanol. Okay. Very good. Okay. So A is the correct answer. What is the reason now? What is the reason? Because as you know, this picric acid is the even more stronger acid than carboxylic acid. So that will be number one. Okay, third will be the most acidic. Then you have acetic acid, that means carboxylic acid. Now out of phenol and cyclohexanol is nothing but this simple. This is cyclohexanol. There is no resonance here. And here you have resonance of this phenoxide ion. So that is why phenol is more stabilized, right? So phenol and then cyclohexanol. Right, so A is the correct answer. Right? Okay, everybody. Never assume that, ma'am, as you know, that acetic acid has, for example, ma'am, acetic acid has, this is ma'am acetic acid. Now, ma'am, acetic acid has just two resonating structures. It has just two resonating structures. Now ma'am, this is having just 2 resonating structures, and ma'am, phenol is having 5 resonating structures. Even then, this is more acidic as compared to phenol because these are equivalent, resonating structures. Equivalent resonating structures gives more stabilization as compared to non-equivalent. Okay, so it does have 5 resonating structure, but they are not equivalent. Okay guys, yes, okay. Next we have 2010 question, which of the following compounds has the most acidic nature? Which of the following compounds has most acidic nature? You have these 4, which has the more acidic nature, everybody. Where there is resonance, maximum resonance in this case. Which has maximum resonance, everybody? 2010 question, which of the following has most acidic nature? As you can see, the level is increasing. The first question that we did, the level was good. Now the level is like, okay, fine, not that much. So here the answer is very simple. Phenol is the correct answer, right? Because of resonating structures. Now next we have NEET 2010. Among the following 4 compounds, everybody, resonating structures talks about stability only, ma'am, not acidic nature, ma'am. No, bacha, resonating does talk about acidic nature. That is interrelated. For example, I am saying this is the phenol, right? How will I define the acidity of this phenol? Acidity of phenol is defined by what is the tendency of it to lose the H positive. So after losing H positive, it is going to form this carbon ion, right? Okay. So now, if this is stable, more is the stability of carbon ion, more is the acidic nature. Okay, so we see the stability of this, right? That is how that is related to each other, right? Okay, yes, perfect. See, that is what you are saying. Yes, ma'am. Okay, now let's come to this question. Among the following 4 compounds, phenol, meta-nitro, this and this, the acidic order. Yes. You can apply all the factors while calculating the stability. All the factors you should apply. Like that is that we have done BARHI. Okay, you should apply all the factors. In this case, you will just see resonating and inductive effect in most of the cases. So this is phenol, methylphenol, meta-nitrophenol, para-nitrophenol. Okay, first is phenol, simple. Next is methylphenol. Okay, methylphenol. You have CH3 group here. Right, next is meta-nitrophenol. Next is para-nitrophenol. You are taking away the electron. Resonance does not apply on the para position, on the meta position. So rule it out. Okay, this will be the most stable. 4th is going to be the most stable here. Okay, 4th is yes, correct answer. Very good. A is going to be the most stable because resonance is applied on the para position or the ortho position, not on the meta position. If you have some electron withdrawing group on the meta position, that is not going to pull the electron because there is no electron density on the meta position. Electron density is on the ortho and para position, and that is why there is benefit of using electron withdrawing group on the para position. It will take away the electrons. So if something is negative, you are taking away the electron, you are making it more stabilized. Right? So you are making this more stabilized. This para product is more stable. Then you will see meta-nitrophenol. Still, as we know, meta-nitrophenol and between phenol. So after this, the answer is clear from this. Okay. After this, you have nitro group on the meta position. Right? Still, it is on the meta position. That is electron withdrawing group. So that is going to make it stable. It is going to make it more stable on the para position. That will be 3rd. After that, there will be phenol, and this is methylphenol. So now see this. You have this phenol, okay? You have this phenol, and next you have this methylphenol. For methylphenol, it is going to give inductive effect. It is going to donate the electrons, making this unstable. Why unstable? As you all know, it will lose the electron. This will lose H positive, it will give O negative. You are giving the electron by inductive effect. You are making it least stable. So this will be least stable. That is, A is going to be the correct answer. Right? Okay, everybody? What just happened? Right? Okay, A is going to be the right answer here. Okay, perfect. Next is NEET 2010 question. When glycerol is treated with excess of HI, it produces. So, well, glycerol is treated with excess of HI. With excess of HI, everybody, A should be the correct answer. Very good. One more para, please. Okay, one more para, please means, what do you mean by one more para product? The glycerol is treated with excess of HI. It produces, glycerol produces 2-hydropropane, allyl iodide, propene or glycerol triiodide. Everybody, glycerol, that is trihydric. Okay, that is trihydric. It is treated with excess of HI. Everybody, what it is going to form? Ma'am, in which case ortho product is better? The question in case of meta, they have given ortho means ortho is more acidic in para nitrophenol. Ortho effect is applied in case of benzoic acid. Okay, that is applied in case of benzoic acid. So in case of acids, we're talking about benzoic acid. If you have ortho product there, okay, so that will always be most stable. Okay, that is ortho effect. Doesn't matter, there will be minus I effect, plus I effect, electron withdrawing, electron donating, doesn't matter. It will be the most stable at ortho product. If we talk about anilines, in case of anilines, the ortho will be the least basic. Okay, and this is ortho is going to be the most acidic. In case of acids and bases, this is totally different. Okay, yes, very good, Rajeev, very good. This is going to be Z. Now let us see, this is glycerol. Okay, now always remember there is excess of HI. Do it step by step. You have 3 HI, right? You replace this HI, this I and this I. Now this will be, this is actually one reaction that we have done in, if you remember, we have done this reaction in case of alkenes. Do you remember this? If we have done this reaction in alkenes, I have taught you this reaction in hydrocarbons. Now you have, this is very unstable, right? 3 carbon atoms and all the adjacent carbon atoms having halide group. This is not a stable condition. So it will lose halide, right? So it will lose halide from this and this position. It will form allyl iodide here. And here, after the formation of this, it is going to react with HI and it is going to form H positive here. Why positive and negative here? The positive is here, wait, this positive is here. Because why positive is here? Wait. It is CH2, this is C double bond, this is CH, this is CH2I. There can be 2 cases, okay? There can be 2 cases, either negative here, positive here, or positive here, or negative here, right? Okay, so in this case, if you see, there can be, if the positive is in this case, you will have CH2I, okay? You will have this alkyl group that is going to donate the electrons, right? And in this case, you have positive on this case. You have positive there. Yeah. So here, this will be eliminated because this is CH3. Okay, this is alkyl group basically, right? Halogen atom is not directly attached to this, and this halogen is not that even electron withdrawing. Okay, so in that case, you will have positive here, negative here, right? So the H positive is going to attack here. You will have the formation of CH3, and the I negative is going to attack here. Right, so we'll have the formation of this one. Yeah. Now this product is formed here. Now again, what will happen? This carbon and this carbon, this I and this I will go. Right? There will be minus I2, and you will have the formation of I2 here. Again, you will have the formation. The HI will be reacted to this alkene, and here you will have the formation of I here. Wait. Something is wrong here. Something is wrong here. Okay, yes, you will have the formation of this. Again, you will have HI, and now this is positive, this is negative, and now this is again same condition. I'm writing it down here. This is CH3, this is CH, this is double bond, this is CH2, right? Again, you will, this pi bond will break here. You will have single bond here, right? And now you will have positive here or here. Okay, if you draw positive on this case, if you draw positive here and the negative here, right? The positive here and the negative here. In that case, this alkyl group is going to give by inductive effect. It is going to stabilize the carbocation, right? Similarly, as of this case. So again, so the I negative is going to attack on this side, I negative here, and the H positive here, right? And hence you will have the formation of 2-idopropane. Right, so they have given you all the options 1, 2, 3, tri-idopropane, then allyl iodide, everything is given here. But remember one thing, that is two halides are not, there are 3 halides actually. So they are not stable on this. This is a very unstable compound. That is why I2 will be released from this. And this is a very important question. Okay, this is a very important question. This can be asked. Okay, okay everybody. Ma'am, it's excess of HI. Yes, excess of HI. Okay. In case of if there is no excess of HI, this reaction will stop here. This reaction will stop here. That is allyl iodide. Okay. This reaction is going to stop here. If they have not mentioned excess of HI, this reaction is going to stop at allyl iodide. Because of excess of HI, again, this double bond will be broken down. Okay? Yeah, it's a little tricky question. Okay? Understood this? If you're not given excess of HI, in that case, this reaction will stop at allyl iodide. Okay? Understood everyone? Now you have 2006 question. Ethylene oxide when treated with grignard reagent that yields primary, secondary, tertiary or cyclopropyl alcohol. You have ethylene oxide that treated with grignard reagents. Everybody in the chat box. Ortho is benzoic. If you have ortho, bilkul sahi. Very good, most basic. Very good. No. With anilines, the ortho effect is opposite. If you're talking about anilines, if you're talking about the basic character, the ortho effect says that at ortho position, that compound is going to be the least acidic, not the most acidic. Okay, least acidic. Okay, yes. So if you have ethylene oxide, okay, this is ethylene oxide, you're going to treat this with the CH3 MgBr. Again, what is going to happen? This bond will be broken down. The more stable carbocation will be formed here, right? So this bond is broken down. So why? This is symmetrical. So either you can break this or you can break this. Totally your choice. Okay. So this bond will be broken down. This is CH2 positive. This is O negative. With O negative, you will have MgBr. This is MgBr. It will be attacked here. This is negative. This will be attacked here. So you'll have CH3, CH2, CH2, O MgBr. After hydrolysis, you will have CH3, CH2, CH2. That is OH. So answer is going to be primary alcohol. Okay. This was symmetrical. So choosing which bond to be broken was easy for you, right? Okay. So which one of the following is not formed? Okay. Yellow precipitate on heating with alkaline solution of iodine. They are talking about iodoform test here. So which is not going to be the iodoform test? We have CH3, C double bond O. That is going to be iodoform test. Secondary alcohol are going to give iodoform test. Methanol is going to give iodoform test. Secondary alcohol or methanol is going to give iodoform test. Okay. So which of the following will not form a yellow precipitate on heating with alkaline solution of iodine? So now this is 2 degree, will not form. Okay, this is again 2 degree. This is ethanol, right? This is 1 degree. Okay, wait. There should be ethanol here. Yeah. Okay. This is methanol. This is methanol, and this is ethanol. Now tell me, which is not going to give which is not going to give iodoform test. Which is not going to give iodoform test, everybody? This one. Right? Understood this? I've already mentioned this to you. You have this ketonic part or carbonyl part 2 degree plus methanol. Okay? All these are going to give positive iodoform test. Ethanol does not give positive iodoform test. In primary alcohol, methanol is the only thing that gives positive iodoform test. Okay? Because it can be. Why? Because this methanol, this is easily converted into CHO. This is converted into aldehydic group. That is why it gives positive test for iodoform. Right? Okay? Next is 2002 question. N-propyl alcohol and isopropyl alcohol can be chemically distinguished by which reagent? You have N-propyl alcohol and isopropyl alcohol that can be chemically distinguished by which reagent? Everybody, reduction PCl5, reduction with potassium dichromate, N-butyl and isopropyl alcohol. What is N-propyl? This is N-propyl. And what is isopropyl? This is this is propyl, right? So this is isopropyl alcohol. So how will you distinguish these two? By reduction. By reduction, everybody. How will you distinguish these two? Everybody, oxidation with potassium dichromate. Very good. So with oxidation with potassium dichromate, this is going to give us simple aldehyde. This is going to give us carboxylic acid because it's a strong oxidizing agent, and this is going to give us ketone. Okay, this is going to give us ketone. Now, this is going to give us carboxylic acid. This is going to give us ketone. Right? Okay. Next question is 2002 question. When phenol is treated with CH, Cl3 and NaOH, the product formed is. Again, simple reaction. Again, very simple reaction. I am not going to give time on this. Okay. So the product formed is CHCl3 and NaOH. What is the product? Salicylic acid. Salicylic acid is the product formed. The product form is salicylic aldehyde, bacha. We are talking about Reimer-Tiemann reaction. Okay. Salicylic acid is formed in case of Reimer-Tiemann with CCl4 or Kolbe's reaction. Okay. So the option is B. Next is 2001 question. Which of the following is correct? On reduction, any aldehyde gives secondary alcohol. On reduction, any aldehyde gives secondary alcohol. On reduction, any aldehyde. Secondary alcohol, methanol does not give. Okay. Reaction of vegetable oil with H2SO4 gives glycerine. Reaction of vegetable oil with H2SO4. What is vegetable oil? What is the formation of vegetable oil? Alcoholic iodine with NaOH gives iodoform. Alcoholic iodine with NaOH film gives iodine. Okay. Sucrose on reaction with NaCl gives inert sugar. So this is basically a combination of so many chapters here. Okay. So it's basically a combination of so many chapters here. अच्छा पिछले क्वेश्चन का सी करा था. Okay. So the correct option is alcoholic iodine with NaOH gives iodoform, that is yellow precipitate. This is wrong. With reaction of this gives glycerin. This is also wrong. Sucrose on reaction with NaCl gives invert sugar. No, wrong. Okay, it gives hydrolysis. It gives invert sugar. Right? Okay. So this is basically iodoform test here. Next is 2014 question. Among the following sets of reactants, which produces anisole? Which produces anisole, everybody? For anisole, what you need to have? CH3, CHORMGX. This produces anisole. You have C6H5NaOH and CH3I. Then you have C6H5OH neutral FeCl3. Then you have C6H5CH3, CH3COClAlCl3. Everybody in the chat box, which is going to give us anisole? Which is going to give us anisole, everybody? Which is going to give us anisole? Yes? Okay. NaOH with... Okay, you're talking about phenol with NaOH and CH3I. Okay? Everybody, what is anisole? What is anisole? This is anisole, right? This is anisole. So just make this product. Everybody, B. Okay. B, ma'am. Okay. Very good. So now you have this CH3. In the first case, there is formation of 2-degree alcohol, right? Because Reimer-Tiemann reaction, this is positive, this is negative, positive. Again, it will react here, and double bond O will be replaced by OH here, right? Then you have C6H5OH with NaOH. With NaOH, it is going to give protons here. It is going to abstract proton here. You will have the formation of this sodium phenoxide. After the reaction with CH3I, you have sodium phenoxide now, right? After the reaction with halide, it is going to form ester, Williamson synthesis, right? Then phenol with FeCl3. Phenol with FeCl3, what is the product? Violet color complex is formed here. Phenol with FeCl3 neutral, a violet color complex like this is formed. This is also we have done this reaction. This is FeCl3 test. Okay, we have done this in practical chemistry. This is the identification of phenol test. Okay, this is for the identification of phenol. Only phenol gives this reaction and a violet color compound is formed here, right? Only phenol gives this reaction. Okay. Then you have CH3COCl with this, and hydrous this, you will have Friedel-Crafts acylation here, right? Okay, para will be the major product here. Then 2014 question, identify Z in the sequence of reaction. You have alkene with HBr and peroxide, then you have C2H5 and ONA. Okay, this is again, everybody answer this again, simple question. Everybody, again a very simple question. Everybody try to answer this. I want all of you to answer this. Very simple, easy question. Firstly, peroxide, that means anti-Markovnikov rule. Negative part on more number of hydrogen, right? Negative part on more number of hydrogen. After that, you have halide, you have alkoxide. There will be ester formation. There will be ether formation, right? Okay. Thank you, bacha. Thank you so much. So, ma'am, when this react with semi-carbide, what is the product? Bacha, don't worry. We are going to do those reaction in aldehyde, ketones and ethers. Okay. Semi-carbazide, everything will be covered in aldehyde, ketones and carboxylic acid. Okay. In detail, we will cover this reaction. Okay. Yes. Now, you will have the formation of ether. Okay. Firstly, everybody answer this. I want all of you to answer this. Why still not no answer? Huh? See, you will have this is HBr, the negative part on more number of hydrogen. That means here you will have the formation of this halide, right? And with this it will form an ether, right? So this is CH3, CH2, CH2, CH3, CH2, CH2, right? CH3, CH2, CH2, wait. This is CH3, CH2, 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 right? These three, right? With O, and then you will have C2H5 here. This is the ether here. Okay? So the answer, this one is correct. Okay? Yes. A is the correct answer. Last question of today. Now let us see who is going to answer this. Last question of today. Let us see who is going to answer this question. Everybody, among the following ethers, which one will produce methyl alcohol on treatment with hot concentrated HI? Okay, which is going to produce the following ether, which will produce methyl alcohol on treatment with hot concentrated HI? Again, that reaction of HI. Okay, I already told you in ether just two questions are asked, that is Williamson synthesis and then the reaction of ether with HI. Okay, very important 2 questions. So now you just need to say which bond you should break. Okay, among this, which one will produce methyl alcohol? Which is going to produce methyl alcohol, everybody? Which is going to produce methyl alcohol? Methyl alcohol. Okay. Everybody, very good. Kamlesh, very good. Saravani, very good. Shri, very good. We are solving, ma'am. Very good, bacha. So me too, correct. बहुत बढ़िया, very good, bacha. Very good. I'm so proud of you. Yes. Option A. Good. Very good. So as you all know, if you have just one trick is we will use here. If you have 1 degree or 2 degree, then lower will be the halide. Lower will be the halide. Okay. Lower will be the halide. If you have 3 degree, then halide will be 3 degree. Halide will be 3 degree. So you can see this is 3 degree. So the halide will be 3 degree. Other will be alcohol. So we know this is the correct answer. So let us see what will happen in this case. Okay. So this is going to give us this will be the halide. Okay. This bond will be broken down. So we will have CH3OH and CH3. This will be the halide part. In this case, you will have this is 2 degree and this is 1 degree. So then the halide will be CH3X because lower will be the halide. Okay. If you have 1 degree or 2 degree, lower will be the halide. In this case, this is 1 degree, this is 1 degree. So this is lower will be the halide, that is CH3X, right? In this case, this is again 2 degree and this is 1 degree. So in this case also lower will be the halide. Okay. So only A is the correct answer. Yes. Very good. Very good, everyone. So now we have completed this. Right? Wait. Have we completed? Yes. So we have completed alcohol, phenol, ether, along with the conversions, all the mechanism, with all the PYQs, right? You are just left with the NCERT conversions, and that is your responsibility. You will be provided the link in the description. You just need to go through that and solve the question yourself. You will be provided with NCERT solutions as well. So, okay, now your task is to do hard work and be consistent. You have 1 day. I want all of you to go through the NCERT questions, and you will see in the link. In the link, you will see this. Okay, you will wait. Either I'll just wait a minute. Okay, just wait a minute. Just wait a minute. I'll show you that. Okay, I'll show you that. Okay, just give me a minute. I'll show you from where you will get those NCERT solutions, right? Just give me a minute. Because if you're doing everything and you're not doing the practice yourself, there is no use there, okay? So, just wait for 1 minute. Okay, so bacha, let us see. That means experimental chemistry. NC class is also showing. Okay, no, there will be aldehyde ketones and carboxylic acid only. There's some miscommunication. Don't worry. On Thursday we will do aldehyde ketones and carboxylic acid only. Okay, don't worry about that. Yes. So bacha, now this is the description here. This is the description here. You will see that NEET best surprise gift. Okay. This is the treasure box, and here you will see the PDFs. Okay. You just need to click it down here. This is 2024 best surprise, and you will just need to click it down. I am clicking this and I get this treasure box here. And here you will have the chapters. This is biology and this is chemistry. And chemistry, let us see where you will find the alcohol phenol. This is alcohol phenol, class 12. These are the PYQs. This is the NEET PYQs. This is the CBSE solutions. Okay, this is the CBSE solution. Okay, for you I'll go through the CBSE solutions here. Okay, here you will have to, here you will have to type your mobile number, which obviously I'm not going to type here, right? After that, after typing your, after filling your number here, just type next here, you will get an OTP, and after that, after filling that OTP, you will get the PYQs, you will get the CBSE PYQs, you will get the NCERT questions, okay? You will get these things, NCERT solution, chapter wise PYQs test here. Class notes will be provided to you here also, okay? Class notes will be provided, and YT link of my lecture will also be provided to you. So do take advantage of this thing, right everybody? Do take advantage of this thing. Wait. Okay, so let us see what you want to say. Yes, finally it was a long session but worth it. Yes, it was an aldehyde ketones, I am already telling you. Just for Thursday, free yourself for aldehyde ketones and carboxylic acid. That is a very long chapter. And we are going to cover like almost 50 to 60, more than 60 PYQs in that. You can see more than 60 PYQs and practice questions as well. We are going to complete. Right, so that is going to be a long lecture, but I really want you to take that session, because in just one go we are going to, with breaks we will have a chill session, okay? We'll take breaks in between. Today I didn't take break because it will go long after, like maybe if I give you break, it maybe this is possible that we are also here for like 1 or 2 p.m. if I give you break here. That's why I didn't give you any break today, right? But in that session I will give you break. So Thursday is going to be a very important session for you, very important. But before that, revise here, okay? Revise all the things here, revise everything that I have listed on in alcohol, phenols and ether, because alcohol, phenols and ether forms the basis of aldehyde ketones and carboxylic acid, and that chapter you can never miss that. You can never miss that chapter. This is the most important chapter, having the most number of naming reactions. Most important reactions are in that chapter. So never miss that chapter. Okay? So on Thursday, we are going to do that. Okay, bacha? Okay. Ma'am, you have escaped. Otherwise, we can get your number. Yeah, I just escaped that, right? Are you able to see me? Are you able to see me or not? Are you able to see me? Yes? Okay. So I'm writing it down here. I am going to conduct the session. Everybody in the chat box, do let me know. Thursday, when you want the session. Thursday, when you want the session. 4 p.m. or 4 p.m. or 5 p.m. 4 p.m. and or 5 p.m. Everybody, 4 p.m. or 5 p.m. 5 p.m. Let us take the session at 5 p.m. for aldehyde ketones and carboxylic acid. Aldehyde ketones and carboxylic acid, along with 60 plus practice question. 60 plus practice question from that chapter itself. I'm telling you, if you have done that chapter with me, you will never, your all marks from aldehyde ketones is like, you will get full marks from aldehyde ketones. I am like guaranteeing you, if you are following my path, only then, okay, only then, right? Okay, 5 p.m, right? Okay, so I am selecting 5 p.m. I am selecting 5 p.m. Right, at 4 a.m. I'll teach you in my dreams, okay? I'll teach you in my dreams at 4 a.m. because that time I am taking dreams. Okay, 5 p.m. that is sorted. 5 p.m. I see you for aldehyde ketones and carboxylic acid, free or slot. That is going to take 4 to 5 hours. I'm telling you, that chapter is going to take 4 to 5 hours easily. If you want to, have like every single topic, if you want to do it in detail, that is going to take time, but I am here for you. So I want all of you to be energetic that day. Okay? Cool? Yes? Perfect. Okay, then I'll see you day after tomorrow, Thursday. But before that, please revise this. This will be updated in that link. You just need to click that link and also do the NCERT questions. We have already done the PYQs. You can also go through the PYQs and do the NCERT exercise questions. Okay, if you don't do the practice yourself, you will be in loss. So do that. Okay. Okay then. Bye-bye. Take care. Okay then, bye-bye, take care, see you all. You can write it in the comment section what the timing you want, but I want to fix the slot at 5 p.m. Okay, that is my wish, to fix the slot at 5 p.m. Right? Okay then, bye-bye, take care, see you all.